Hi friends, my name is Maruti and I'm the co-founder of Cracku. I'm also a graduate from IIT Bombay, Computer Science. I graduated in 2008 and I started Cracku after that. In this video, we are giving 50 very important questions for JEE Mains. Most of these questions are from the January session of JEE Mains. Initially, the question will be shown to you and after that there will be a video solution. Please pause the video when the question is shown, try to solve it on your own, and after that you can try to watch the video solution. If you have any doubt in any one of these 50 questions, please do comment below this video. I look at all the comments and I'll try to answer them to the best of my ability. In addition to it, Cracku is providing a lot of free resources for students who are preparing for JEE. We are providing a formula PDF which contains all the important formulas in maths, physics and chemistry. The links for the formula PDF are given in the description of this video. You can download them completely for free and try to use them. We are also providing a very nice question bank which contains thousands of questions which are very relevant for JEE Mains, all of them with detailed solutions. You can access the question bank and the link to access the question bank is again given in the description of this video. Going forward, we will be uploading a lot of very important videos for students who are preparing for JEE, both mains as well as advanced. So please do subscribe to this channel and please do share it with your friends. If there is any video that you are looking for, any particular topic that you want any good explanation, please feel free to comment below this video and we'll try to upload those videos as soon as we can. Thank you. In this question, we are told that f of x is 2 to the power x plus 2 plus 16 divided by 2 to the power 2x plus 1 plus 2 to the power x plus 4 plus 32. And we are asked to calculate the value of an expression which is f of 1 by 15 plus f of 2 by 15 plus dot 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 till f of 59 by 15. The first thing you should have to recognize over here is the first term is 1 by 15 and the last term is 59 by 15. The sum of both of them is equal to 4, which is 60 by 15. That should give us a clue about how to proceed further. Firstly, if you are looking at f of x and if you are trying to simplify it, f of x is equal to 2 to the power x plus 2, which is 2 to the power x into which is 4 plus 16 divided by 2 to the power 2x plus 1, which is 2 to the power 2x into 2 plus 2 to the power x into 2 to the power 4, which is 16 plus 32. Now, if you divide the numerator and denominator with 2, we are going to get 2 to the power x into 2 plus 8 divided by 2 to the power 2x plus 2 to the power x into 8 plus 16. Now the denominator is interesting. The denominator is interesting because this is 2 to the power x plus 4 whole square. Similarly, the numerator is 2 times 2 to the power x plus 4. That is, the numerator is 2 times 2 to the power x plus 4 and the denominator over here is 2 to the power x plus 4 whole square. If you are simplifying it, this is equal to 2 divided by 2 to the power x plus 4. This is the value of f of x. Now remember what we discussed earlier. We discussed that the first term plus the last term is equal to 4. So let us calculate f of 4 minus x. F of 4 minus x is equal to 2 divided by 2 to the power 4 minus x plus 4, which is equal to 2 to the power 2 into 2 to the power x, because I am going to multiply the numerator and denominator with 2 to the power x. This is 2 to the power 4 plus 4 into 2 to the power x. Now if you divide the numerator and denominator with 2, this is equal to 2 to the power x divided by 2 into 2 to the power x plus 8, which is equal to 2 to the power x minus 1 divided by 2 to the power x plus 4. Because again I am dividing the numerator and denominator with 2. So what do we have over here? What is f of x plus f of 4 minus x? F of x plus f of 4 minus x is equal to 2 plus 2 to the power x minus 1 divided by 2 to the power x plus 4. This is simply equal to 1 by 2. So f of x plus f of 4 minus x is equal to 1 by 2. What we are asked is, what is the value of f of 1 by 15 plus f of 2 by 15 plus dot 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 plus f of 59 by 15. If you assume that this is equal to s is also equal to f of 59 by 15, where I am just going to reverse all the terms, plus f of 58 by 15 plus dot 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 plus f of 1 by 15. Now the sum of both of them would tell us that 2s is equal to f of 1 by 15 plus f of 59 by 15, which is equal to 1 by 2, plus f of 2 by 15 plus 58 by 15, which is equal to 1 by 2, plus dot 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 dot, and over here also is 1 by 2. And there are 59 such 1 by 2s. So this is equal to 59 by 2. This is the value of 2s. So the value of 4s is equal to 59 and the value of 8s is equal to 118. What we are required to calculate is 8 times the value of f of 1 by 15 plus dot 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 till f of 59 by 15. So the answer for this question, which is 8 times this, is equal to 118, which is option B. In this question, we are given an equation. This is a quadratic equation which has two modulus. One modulus is modulus of x plus 3, another one is modulus of x minus 1. So this has two inflection points. One inflection point is when x is equal to minus 3 and another inflection point is when x is equal to 1. So because there are two inflection points, let us consider three cases. The first case is when x is less than minus 3. The second case is when x lies between minus 3 and 1. The third case is when x is greater than 1. Let us consider the first case. Let us consider the first case first, where x is less than minus 3. If x is less than minus 3, x plus 3 will be less than 0. Therefore, modulus of x plus 3 is equal to minus x minus 3. If x plus 3 is less than 0, x minus 1 is definitely less than 0. Therefore, modulus of x minus 1 will be equal to 1 minus x. So what does this quadratic equation look like? It will be x into x plus 3, which is x into minus x minus 3 plus modulus of x minus 1, which is 1 minus x minus 2 is equal to 0. Or minus x square minus 3x minus x plus 1 minus 2 is equal to 0. If you simplify it, you are going to get x square plus 4x plus 1 is equal to 0. This has two roots. The roots are x is equal to minus 4 plus or minus square root of b square, that is 16, minus 4ac, which is 4, divided by 2. This will equal minus 4 plus or minus square root of 12 by 2. This is equal to minus 2 plus or minus square root of 3. What is the value of square root of 3? Square root of 3 is approximately 1.732. So this will be either approximately minus 3.7 or something like minus 0.27. But in this particular case, we are looking for only values of x which are less than minus 3. So if you are looking for values of x which is less than minus 3, this is not counted, this is counted. So in the first case, we have one solution. What about the second case, where x lies between minus 3 and 1? If x lies between minus 3 and 1, x plus 3 will be greater than or equal to 0. So modulus of x plus 3 is equal to x plus 3. But because x is less than 1, modulus of x minus 1 will be equal to 1 minus x. So now how does the quadratic equation look like? The quadratic equation we have is x into modulus of x plus 3 plus modulus of x minus 1 minus 2 is equal to 0. So that will be x into x plus 3 plus 1 minus x minus 2 is equal to 0. This is x square plus 3x plus 1 minus x minus 2 is equal to 0. This is x square plus 2x minus 1 is equal to 0. So the value of x is minus 2 plus or minus square root of 4 plus 4, which is 8, divided by 2. This is equal to minus 1 plus or minus square root of 2. What is the value of square root of 2? Square root of 2 is approximately 1.414. So this will be equal to either minus 2.41 or it will be equal to minus 1 plus root 2. So this is 0.41. These are the two values. Both of them lie between minus 3 and 1. This is the interval for this particular case where we want x to lie between minus 3 and 1. Both the roots that we got, minus 2.41 and 0.41, lie in that particular interval. So this particular case has two solutions. What about the third case where x is greater than 1? If x is greater than 1, x plus 3 will be greater than 0. So modulus of x plus 3 will be x plus 3, and x minus 1 in this particular case will be greater than 0 because x is greater than 1. So modulus of x minus 1 is equal to x minus 1. So now the given quadratic equation becomes equal to x into x plus 3 plus x minus 1 minus 2 is equal to 0. This is x square plus 3x plus x minus 1 minus 2 is equal to 0, which is x square plus 4x minus 3 is equal to 0. Or the value of x is equal to minus 4 plus or minus square root of 16 plus 12 divided by 2. This is equal to minus 4 plus or minus square root of 28 divided by 2. This will equal minus 2 plus or minus square root of 7. What is the value of square root of 7? Square root of 7 is approximately equal to 2.64. So this is either equal to minus 4.64 or this is equal to 0.64. In this case, we are looking only for values which is greater than 1. This is not greater than 1, this is not greater than 1. So this case where x has to be greater than 1 has no solutions. So the correct answer is 0 solutions. So the total number of solutions including all the three cases is 1 plus 2, which is equal to 3, which is option C. In this question, we are given a logarithmic equation and we are asked to calculate the sum of all the real solutions of this given logarithmic equation. If you are looking at the first logarithm, the argument is 6x square plus 28x plus 30 and the base is x plus 3. So if you are looking at 6x square plus 28x plus 30, let us try to factorize it. This will be equal to 6x square plus 18x plus 10x plus 30. This is equal to 6x plus 10 into x plus 3. Now this is basically the base of the given logarithm. So the given logarithm can be simplified to equal log of 6x plus 10 to the base x plus 3 plus 1. And then we have, this is the left hand side and the right hand side is, this is equal to 5 minus 2 times log of 6x plus 10, which is now the argument of this particular logarithm. And the argument over here is x square plus 6x plus 9. Now what is x square plus 6x plus 9? X square plus 6x plus 9 is equal to x plus 3 whole square. So the right hand side is equal to 5 minus 2 times log of, this is x plus 3 whole square to the base 6x plus 10. So that is 5 minus 4 times log of x plus 3 and the base is 6x plus 10. If you are bringing both the logarithms to the left hand side, we are going to get log of 6x plus 10, and this is x plus 3, plus 4 times log of x plus 3, and this is 6x plus 10. This is equal to 4. Now what you should notice is this is of the form log of a to the base b plus 4 times log of b to the base a. Because this is the argument and the base are getting interchanged in the second term. So if you assume that this part over here is say p, this part over here will be 1 by p. So if you assume that p is equal to log of 6x plus 10 to the base x plus 3, what we are going to get is p plus 4 by p is equal to 4, or p square minus 4p plus 4 is equal to 0. This is p minus 2 whole square is equal to 0, or the value of p is equal to 2. Now again remember what is p? P is log of 6x plus 10 to the base x plus 3. So log of 6x plus 10 to the base x plus 3 is equal to 2, or 6x plus 10 is equal to x plus 3 whole square, which is equal to x square plus 6x plus 9. We can cancel 6x on both sides. So x square is equal to 1, or the value of x is either 1 or x is equal to minus 1. Now one thing you should notice is, especially when logarithms are involved, we want to figure out if all the logarithms are defined or not. When is a logarithm which is of the form a to the base b defined? For this to be defined, a has to be greater than 0, that is the argument has to be greater than 0, b has to be greater than 0, base also has to be greater than 0, and base cannot be equal to 1. These are the three conditions that are needed for the logarithm to be defined. If you are looking at x is equal to 1, 6x square plus 28x plus 30 is greater than 0. X plus 3 is greater than 0. And x plus 3 is not equal to 1. Similarly over here also, when x is equal to 1, this logarithm is clearly defined. When x is equal to minus 1 also, this is greater than 0. This will be equal to 2, which is greater than 0 and not equal to 1. This also will be defined. So the logarithms are defined when x is equal to 1 and when x is equal to minus 1. So both of them are real solutions for the given equation. And what is the sum of both of them? The sum of both of them is 1 plus minus 1, which is equal to 0. So the answer for this question is option B. In this question, we are given a set and we are asked to calculate the number of elements in that particular relationship, such that x and y are integers and 4x square plus y square is less than 52. So let us consider some cases. The inequality that we are looking for is 4x square plus y square is less than 52. Now there will be a lot of symmetry here, that is some parts of, there will be some elements which say if x is positive, the negative value will also be part of it. Similarly, if y is positive, the negative value will also be part of it. So to count this quickly, let us consider some cases. The first case is that if x is equal to 0 and y is equal to 0, this inequality is satisfied because the left hand side will be 0. So that is one case. If x is equal to 0 and y is not equal to 0, the inequality that we have will be equal to y square is less than 52. So the values y can take are 1, 2, till 7. This is positive value. Similarly, minus 1, minus 2, till minus 7. So the total number of cases possible are 14 cases. What will happen if y is 0 and x is not equal to 0? If y is 0 and x is not equal to 0, we have 4x square is less than 52, or x square is less than 13. So the values that x can take are 1, 2 and 3. This is if x is positive, and minus 1, minus 2 and minus 3 if x is negative. So here we have 6 cases. Now let us consider the situation where x is not equal to 0 and y is not equal to 0. For the sake of simplicity, let us assume that x is greater than 0 and y is greater than 0. Because for every such case, we'll find 4 cases. We'll just put the negative value of x and the negative value of y. So there will be 4 cases possible. But just to enumerate, for the sake of simplicity, let us assume that x is greater than 0 and y is greater than 0. So you have 4x square plus y square is less than 52. Both x and y are greater than 0. So now let us assume that x is equal to 1. Then what is the value of 4x square? 4x square will be 4, or you will have y square is less than 48. So the values y can take are 1, 2, 3, 4, 5 and 6. There are 6 cases. Again, we are only assuming that y is positive and x is positive. If x is equal to 2, then 4x square will be, x square will be 4, 4x square will be 16, so y square will be less than 36. So the values that y can take are 1, 2, 3, 4 and 5. So there are 5 cases. If x is equal to 3, 4x square will be 36. So we'll have y square is less than 16. So the value of y is 1, 2 or 3. So we have 3 cases. If x is equal to 4, 4x square is 64 and we won't have any solutions for this. So in this particular case, the total number of cases is 6 plus 5 plus 3, which is 14 cases. But like we discussed, these are only cases where x is greater than 0 and y is greater than 0. We'll have exactly the same number of cases where x is less than 0 and y is greater than 0. We can just put x is minus 1, minus 2 and minus 3, we'll get the same number of cases. Similarly, we'll have the exact same number of cases where x is greater than 0 and y is less than 0. For example, in the same case, we can put y is minus 1, minus 2, minus 3, minus 4, minus 5 and minus 6. And similarly, we'll have the same number of cases when x is less than 0 and y is less than 0. We can put x is minus 1, y is minus 1, minus 2, minus 3, minus 4, minus 5 and minus 6. So the total number of cases, like we discussed earlier, this has to be multiplied by 4. So this is 56. Overall, the total number of cases for this given inequality will be 56 plus 6 plus 14, which is 76, plus 1, which is equal to 77. So the answer will be option D, which is 77. In this question, we are told that f of x is log of 18x square minus 11x plus 1 to the base 10x square minus 17x plus 7. We are told that the domain is given and there are some variables a, b, c, d and e. We are required to calculate the value of 90 times a plus b plus c plus d plus e. So in this question, we have to first figure out the domain of the given function. After that, it becomes easy. Now, if you are given a logarithm, something like log of a to the base b, when is this defined? When is this logarithm defined? The logarithm is defined when a, the argument is greater than 0 and the base b has to be greater than 0 and the base b should not be equal to 1. These are the 3 conditions that are needed for a logarithm to be defined. If the argument is greater than 0, we want this part to be greater than 0. So we want 18x square minus 11x plus 1 to be greater than 0. We can factorize this to equal 18x square minus 9x minus 2x plus 1 to be greater than 0. This is 9x minus 1 into 2x minus 1 should be greater than 0. So x has to be either less than 1 by 9 or x has to be greater than 1 by 2. This is the condition for the argument to be greater than 0. When is the base greater than 0? Base is 10x square minus 17x plus 7. So we want 10x square minus 17x plus 7 to be greater than 0. Or we want 10x square minus 10x minus 7x plus 7 to be greater than 0. This is 10x minus 7 into x minus 1 should be greater than 0. So we want either x to be less than 7 by 10 or x has to be greater than 1. This is the case where the base is greater than 0. But we want both of them to be true. We want the argument to be greater than 0. We want the base to be greater than 0. So both of these intervals, whatever is the intersection, will be the domain. So basically we have to look for whatever is the intersection of both of these intervals. So that intersection will be x belonging to minus infinity to 1 by 9, union 1 by 2 to 7 by 10, union 1 to infinity. But remember one more thing, the base cannot be equal to 0. So this cannot happen. What is the value of x for which the base is equal to 0? 10x square minus 17x plus 7 is equal to 1. Remember that the base cannot be equal to 1. And at what value of x is the base equal to 1? The base is equal to 1 at 10x square minus 17x plus 6 is equal to 0. This is 10x square minus 12x minus 5x plus 6 is equal to 0. This is 2x minus 1 into 5x minus 6 is equal to 0. So the value of x is equal to 1 by 2 or it is equal to 6 by 5. You will notice that in the interval that we have, 1 by 2 actually is not part of it. But 6 by 5 is part of 1 to infinity. So the domain is whatever is the interval given minus 6 by 5. So if you are looking at the values of a, b, c and d and e, a is equal to 1 by 9, b is equal to 1 by 2, c is equal to 7 by 10, d is equal to 1 and e is equal to 6 by 5. This is the value of a, b, c, d and e. What is 90 times a plus b plus c plus d plus e? That is 90 times a will be 10 plus 90 times b is equal to 45 plus 90 times c is equal to 63 plus 90 times d will be just equal to 90 plus 90 times e. What is 90 times e? This will be 108. If you are adding this, 45 plus 63 is 108. 108 plus 108 is 216. 90 plus 10 is 100. 100 plus 216 is 316. So the answer for this particular question is equal to option B, which is 316. In this question, we are given two sets, A and B, and we are asked to first calculate the values of A and B and then figure out which of the four options is correct. So let us try to solve it. Let us first try to understand what is the value of A. A represents all the values of x for which modulus of x minus 10 is less than or equal to 6. So if you have modulus of x square minus 10 to be less than or equal to 6, it would imply that x square minus 10 is greater than or equal to minus 6 and this is less than or equal to 6. Because remember that if you have something like modulus of x, modulus of an expression is less than or equal to y, it would imply that x will lie between minus y and plus y. Similarly over here, x square minus 10 will lie between minus 6 and plus 6. If you add 10 to it, you are going to get 4 is less than or equal to x square is less than or equal to 16. This part of the inequality will tell us that x square is less than or equal to 16. So x will belong to minus 4 and plus 4. This part of the inequality will tell us that x square is greater than or equal to 4. So x will either be less than or equal to minus 2 or x is greater than or equal to 2. This has to be true and this has to be true. This would imply that x has to belong to minus 4 comma minus 2 union 2 comma 4. And note that x can be minus 4, x can be minus 2, x can be 2 and x can be 4. This is the value of the set A. What about set B? Set B will tell us that modulus of x minus 2 is greater than 1. If modulus of x minus 2 is greater than 1, it would imply that either x minus 2 is greater than 1 or it would imply that x minus 2 is less than minus 1. One of these two has to happen. So either x is greater than 3 or x is less than 1. This is the value of b. So b would be minus infinity to 1. Note that 1 is not part of the interval, union 3 to infinity. This is the value of b. This is the value of a. Let us look at the four options. The first option says a union b is minus infinity to 1, union 2 to infinity. This is a and this is b. So what is the value of a union b? A union b will be minus infinity to 1. 1 is not part of it. Union 2 to infinity. Note that 1 is not part of it, but 2 will be part of the interval. Now if you are looking at the option, here 2 is not part of the interval. So this is not the correct answer. 2 has to be part of a union b. If you are looking at the second option, which is a minus b. So we are looking for the elements which are part of a but not part of b. If this is a and if this is b, a minus b will be, it will have nothing from minus 4 to minus 2 because all of them are part of b. Between 2 and 4, 2 will be part of it, 3 will be part of it, both of them will be part of a minus b. So a minus b will be square brackets of 2 to square brackets of 3 because 2 is part of a and 3 is not part of b. So both 2 will be part of a minus b and 3 will be part of a minus b. So this is the value of a minus b, which is again not this because you want this to be a square bracket. If you are looking at the third option, what is b minus a? That is, we are looking for elements which are part of b but not part of a. If you are looking at b minus a, minus infinity to 1, so you will have elements from minus infinity to minus 4. From minus 4 to minus 2, it is part of both a and b, so it will not be part of b minus a. Union minus 2 to 1. Note that minus 2 is part of a, so it will not be part of b minus a. And after that, you have union 4 to infinity. Again, 4 is part of a, so 4 will not be part of a. 4 will not be part of b minus a. This will be the part of b minus a. If you are looking at it, this will exactly match. So this is the correct answer. Just for the sake of completeness, let us look at option D also, which is a intersection b. So we want elements which are part of both a as well as b. A intersection b will be, this is a and this is b. A intersection b should be part of both a and b. So this will be minus 4 to minus 2. Both of them are part of a, both of them are part of b. In a, we have 2 to 4, both of them included. In b, we have 3 to infinity, 3 is not included. So this will be union 3 to 4. 3 will not be included, but 4 will be included. That is a intersection b. Is it matching with the option given? It is not matching with the option given because this has to be a curved bracket. This has to be a round bracket. 3 is not part of b, so 3 is not part of a intersection b. So this also is not the correct answer. In this question, we are told that there is S which denotes the set of 4-digit numbers ABCD such that A is greater than B is greater than C is greater than D, and P denotes the set of 5-digit numbers having the product of its digits equal to 20. Then N of S plus N of P, that is the number of elements in S and the number of elements in P, is what we are required to calculate. If we have a 4-digit number like this and we want the digits to be in ascending order and we want the digits to be in descending order, in how many ways can we do it? We'll consider two cases. The first case is that the last digit is equal to 0. If the last digit is equal to 0, we want the first 3 digits to be in descending order. And they have to be amongst the digits 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in how many ways can we select 3 digits from those 9 digits? We can select them in 9C 3 ways. And once we select the digits, for example, if you select the 3 digits as 2, 4 and say 7, there is only one way in which we can arrange them in descending order. If we are selecting 2, 4 and 7, it will be just 7, 4, 2, 0. This is the only way in which we are going to have all the digits in descending order. But the number of ways in which we can select the 3 digits 7, 4 and 2 is 9C3 ways. 9C3 is equal to 9 into 8 into 7 divided by 6. This is 12. This is 84 ways. So in 84 ways, the last digit will be 0 and all the digits will be in descending order. Now suppose the last digit is not equal to 0. Then we need to select 4 digits out of again the same 9 digits and they can be selected in 9C 4 ways. Once we select the 4 digits, for example, suppose the 4 digits selected are 1, 3, 6 and 9. If the 4 digits selected are 1, 3, 6 and 9, there is only one way in which we can arrange them in descending order. That will be 9, 6, 3, 1. And the number of ways in which we can select the 4 digits is 9C 4 ways, which is equal to 9 into 8 into 7 into 6 divided by 24. 9 into 8 is 72. 72 divided by 24 is 3. This is equal to 126. So the number of elements in S is equal to 84 plus 126, which is equal to 210 ways. Now let us try to figure out the number of digits where the product of the digits is 20. We need 5-digit number. Let us assume that the 5-digit number is A, B, C, D and E. The product of these digits is 20. 20, if you are doing the prime factorization, is 2 square into 5. What I am essentially saying is that one of these 5 digits has to be 5. If there is no 5 in this 5 digits, the product of the 5 digits will not be equal to 20. Once we have one of the digits to be 5, in how many ways can we select which digit is 5? That can be selected in 5 ways. That is, either A can be 5 or B can be 5 or C can be 5 or D can be 5 or E can be 5. Once that is selected, we are left with 4 digits. Let us put 4 blanks and the product of these 4 blanks is equal to 4. Because 1 5 is taken care of. In how many ways can we select 4 numbers such that their product is equal to 4? That is possible if 2 of them are 2 and 2 of them are 1, or one of them is 4 and the remaining 3 are 1. But again, these 4 numbers can be arranged in 6 ways. How did we get 6? There are 4 digits. Out of those 4 digits, we have to select 2 digits which are 2. They can be either the first and the second one, or first and third one, or first and fourth one, or multiple ways that can be done. That is equal to 4C2, which is equal to 6 ways. Or we can have 1 4 and 3 ones. This can be selected in 4 ways. Because the only choice we have to make is which of the 4 digits is what. The only choice we have to make is which of the 4 digits is equal to 4. That can be either the first one or the second one or the third one or the fourth one. That can be selected in 4 ways. So the total number of ways in which the product is equal to 4 is 10 ways. And selecting which digit is 5 can be done in 5 ways. So the total number of ways in which the product is equal to 20 is 5 into 10, which is equal to 50 ways. This is the value of n of p. Therefore, the value of n of s plus n of p will be 210 plus 50, which is equal to 260. In this question, we are given 2 sets. A is 1, 2, 3, 4 dot 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 till 10 and B is m divided by n where n belongs to A. So A has to be one of 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and m is less than n, but the greatest common divisor of m and n is 1. That is, m and n have to be relatively prime. We are required to calculate the number of values or the number of the number of terms in B. That is what we are required to calculate. So let us assume that when n is equal to 1, the values that m can take is nothing, because we want m to be less than n. So there are 0 values. When n is equal to 2, m can be equal to 1, so there is 1 value that m can take. When n is equal to 3, m can be either 1 or 2, so it can take 2 values. When n is equal to 4, m can be either 1 or 3, so again it can take 2 values. When n is equal to 5, m can be 1 or 2 or 3 or 4, so it can take 4 values. When n is equal to 6, m can be either 1, it cannot be 2 or 3 or 4, or it can be 5. So again it can take 2 values. When n is 7, because 7 is a prime number, it is very easy to calculate the values that m can take. M can be 1 or 2 or 3 or 4 or 5 or 6, so it can take 6 values. When n is equal to 8, m can be 1, it cannot be 2, it can be 3, it cannot be 4, it can be 5, it cannot be 6, it can be 7. So there are again 4 values that m can take. If n is equal to 9, m can be 1 or 2, it cannot be 3, it can be 4 or 5, it cannot be 6, or it can be 7 or 8. So m can take 6 values. Similarly, when n is equal to 10, m can take 1, it cannot be 2, it can be 3, it cannot be 4 or 5 or 6, it can be 7, it cannot be 8, it can be 9. So m can take 4 values. So what is the total number of values that m and n can take? That will be 4 plus 6, which is 10, plus 4 plus 6, another 10, plus 2 plus 2 plus 4 plus 2, another 10. So 10 plus 10 plus 10, 30 and 1. So this will be 31, which is option B. The smallest positive integral value of A, for which the roots x to the power 4 minus a into x square plus 9 are real and distinct. So here, if you assume that x square is equal to p, what is the quadratic equation looking like? It is p square minus ap plus 9 is equal to 0. Now for this, for the roots to be real, we want the discriminant of this quadratic equation to be greater than or equal to 0. And what is the discriminant of this given quadratic equation? The discriminant is a square minus 36. So we want a square minus 36 to be greater than or equal to 0 for the roots to be real. But we also want the roots to be distinct. Remember what we discussed. If d is greater than 0, we will have 2 real roots. If d is equal to 0, we will have 1 real root. Or both the roots are basically equal to each other. So we will have 1 distinct real root. If d is less than 0, we will have no real roots. So here we want this particular case to happen. So d being greater than or equal to 0 will not suffice. D has to be strictly greater than 0. Because if d is equal to 0, the roots will be real, but they won't be distinct. They will be equal to each other. So a square has to be greater than 36 or a has to be greater than 6, because we are only looking for positive integral values of a. So the smallest value that a can take will be equal to option B, which is equal to 7. We are required to calculate the sum of all roots of the equation x minus 1 whole square minus 5 times modulus of x minus 1 plus 6 is equal to 0. To solve this question, let us assume that modulus of x minus 1 is equal to a new variable called p. Because we are seeing x minus 1 whole square and modulus of x minus 1. So if you assume that modulus of x minus 1 is equal to p, it becomes easier. So P has to be greater than or equal to 0. This is the first thing. And interestingly, x minus 1 whole square is equal to modulus of x minus 1 whole square, which is equal to P square. Because x minus 1 whole square is always greater than or equal to 0, it will actually equal modulus of x minus 1 whole square. So the given quadratic equation becomes equal to P square minus 5P plus 6 is equal to 0, and we want P to be greater than or equal to 0. So this would imply that this can be simplified to equal P minus 2 into P minus 3 is equal to 0. So we have two cases, either P is equal to 2 or P is equal to 3. But what is P? P is simply equal to modulus of x minus 1. So modulus of x minus 1 is equal to 2 or modulus of x minus 1 is equal to 3. So x minus 1 is equal to 2 or x minus 1 is equal to minus 2 or x minus 1 is equal to 3 or x minus 1 is equal to minus 3. So the value of x is equal to 3 or x is equal to minus 1. Here x is equal to 4 or x is equal to minus 2. So the given equation has 4 roots. The roots are 3 minus 1, 4 and minus 2. The sum of these two is equal to 2. The sum of these two also is equal to 2. So the overall sum of all the roots will be equal to 4, which is option A. In this question, we are told that alpha and beta are the roots of the equation x square plus 2ax plus 3a plus 10 is equal to 0. This is a quadratic equation. Every quadratic equation which is of the form ax square plus bx plus c is equal to 0 has something called a discriminant. Let us call the discriminant d. The discriminant of a quadratic equation is b square minus 4ac. Now if b square minus 4ac is greater than 0, the quadratic equation will have two real roots. If b square minus 4ac is equal to 0, it will have one distinct real root. That is, it will have two real roots which are equal to each other. Whenever you are told that the roots are the same or something like that, it would mean that b square minus 4ac is equal to 0. If b square minus 4ac is less than 0, the quadratic equation will have 0 real roots. That is, both the roots will be complex. Here we are basically asked that we will have two roots, alpha and beta. Alpha is less than 1 is less than beta. So both the roots are real. So we want b square minus 4ac to be greater than 0. What is b square minus 4ac? That will be 4a square minus 4 times 3a plus 10. This has to be greater than 0. You can divide this entire equality with 3 inequality. So this is a square minus 3a minus 10 is greater than 0. This is a square minus 5a plus 2a minus 10 is greater than 0. You can take, this is basically a minus 5 into a plus 2 is greater than 0. So a is either less than minus 2 or a is greater than 5. This is the condition that is needed for the quadratic equation to have two real roots. In addition to it, we have to look at the condition such that one of the root is less than 1 and one of the root is greater than 1. For that, if you are having a quadratic equation like this, if say it has two roots like this, we want one to fall between both the roots. This is alpha and this is beta. If you want one to fall between both of the roots, what is the condition that is needed? The condition that is needed is that at 1, this point has to be less than 0. That is, f of 1 has to be less than 0. What is f of 1? Instead of x, substitute the value of x to be equal to 1 over here. This will be 1 plus 2a plus 3a plus 10 has to be less than 0. That is 5a plus 11 has to be less than 0, or a has to be less than minus 11 by 5. So we want a to be less than minus 11 by 5. This is needed. We want a to be either less than minus 2 or a to be greater than 5. If you are looking at it, the interval in which both the conditions are satisfied is when a belongs to minus infinity to minus 11 by 5. So the answer for this question will be option A. In this question, we are asked to calculate the product of all the solutions of the equation e to the power 5 log x to the base e whole square plus 3 is equal to x to the power 8. We see that in this exponent we have log x to the base e. So let us first write down the equation that is given. This is e to the power 5 times log of x to the base e whole square plus 3 is equal to x to the power 8. If you are taking log to the base e on both sides, the left hand side, for example, is of the form e to the power p, where p is just log x to the base e whole square plus into 5 plus 3. If you are taking log to the base e for this particular term, we are going to get just p. And on the right hand side, because this is x to the power 8, if you are taking log to the base e, you are going to get 8 times log x to the base e. So, if you are taking log to the base e on both sides of the equation, the left hand side becomes equal to 5 log x to the base e whole square plus 3, and the right hand side becomes equal to 8 times log of x to the base e. If you assume that log of x to the base e is equal to a new variable, say a, the given equation is 5a square plus 3 is equal to 8a, or 5a square minus 8a plus 3 is equal to 0. This is 5a square minus 5a minus 3a plus 3 is equal to 0, or we can factorize this as 5a minus 3 into a minus 1 is equal to 0. So a is either equal to 3 by 5 or a is equal to 1. But what exactly is a? A is log of x to the base e. So log of x to the base e is either equal to 3 by 5 or log of x to the base e is equal to 1. So x is either equal to e to the power 3 by 5 or x is equal to e. And the product of both of them, both the roots, is e to the power 8 by 5. So the answer for this particular question will be option A, which is e to the power 8 by 5. In this question, we are told that the letters of the word Udaipur are written in all possible ways, with or without meaning, and these words are arranged as in a dictionary. The rank of the word Udaipur has to be calculated. So how many letters are there in Udaipur? You have U, D, A, Y, P, U, R. So there are 7 letters, out of which there are 2 U's and 5 are distinct. In a dictionary, the first letter is A. So if you are looking at the 7 letter words starting with A, we will have 6 letters remaining, out of which U will be repeated 2 times. So the total number of words possible which are formed using these 7 letters and the starting letter is A is 6 factorial divided by 2, because we have 2 U's. This will be 720 by 2, which is 360. After A in the dictionary, we are going to get D. So the number of words which are starting with D will be again equal to 360. After D, we are going to get P, and again there will be 360 words. And after P, we are going to get R. So the number of 7-letter words which start with R again is 360. All of these words are ahead of Udaipur in the dictionary. After R, we are going to get U. Now, what are the words which are ahead of Udaipur which are starting with U? In Udaipur, the second letter is D. So, if say the second letter is A, we have 5 letters remaining. What are those 5 letters? We will have D, Y, P, U, R. If you notice these 5 letters, there is no repetition because the only letter which was repeated is U, which was already used. So these 5 letters D, Y, P, U, R can be arranged in 120 ways. All of these 120 are ahead of Udaipur in the dictionary because all of them will have the second letter as A. After that, we are going to get U and D, and the first letter in the dictionary is A, so it will be over here. Now, what are the letters which are remaining? You have U, D, A. We are left with Y, P, U, R. In Udaipur, next will be Y. But all the words which are starting with U, D, A, P or U, D, A, R or U, D, A, U, all of them are ahead of Udaipur in the dictionary. Here we basically have 3 letters each in each of these cases, and they can be arranged in 6 ways. So this can be arranged in 6 ways, this can be arranged in 6 ways, and this also can be arranged in 6 ways. All of these words are ahead of Udaipur in the dictionary. Next we are going to get U, D, A, Y, and what are the 3 alphabets that are remaining? We have P, U, R. Now the first amongst P, U, R in the dictionary is P, so again we are going to put it over here. Now we are left with U and R. Udaipur is this letter, but because we can have R and U also possible, this is one other word, and finally we are going to get Udaipur. So the rank of Udaipur is the sum of all of them. That is 360 plus 360 plus 360 plus 360 is 1440 plus 120 plus 3 times 6 is 138 plus 2 is 140. This will be 1580. So the rank of Udaipur in the dictionary is 1580, which is option A. In this question, we are told that from all the English alphabet, 5 letters are chosen and they are arranged in alphabetical order. So let us assume that these are the 5 letters, they are arranged in alphabetical order. We want to calculate the number of ways in which the middle letter, that is this letter, is M. All of these letters are arranged in alphabetical order. So this would imply that these 2 letters are before M and these 2 letters are after M. How many letters are before M? M is the 13th letter of the English alphabet. So here there are 12 alphabets before M, out of which we need to select 2. They can be selected in 12C 2 ways. How many alphabets are after M? There are 13 alphabets after M, out of which we need to select 2. So they can be selected in 13C2 ways. What is 12C2? It is 12 into 11 by 2. Into what is 13C2? It is 13 into 12 by 2. This is 6. This is 6. So this is equal to 66 into 78. What is 66 into 78? It is 5148. So the answer for this particular question is option A, which is 5148. In this question, we are told that there is a set of 50 natural numbers from 1 to 50. We are required to calculate the value of P and Q and then add P plus Q. What is P? P is the number of elements in S such that 6 to the power M plus 9 to the power n is a multiple of 5. Q is the number of elements m and n in S such that m plus n is a perfect square. So let us first calculate the value of P. To calculate the value of P, we need to calculate the number of values of m and n such that 6 to the power m plus 9 to the power n is a multiple of 5. Now when m is odd, the remainder when 6 to the power m is divided by 5 is 1. Similarly, because 6 is 5 plus 1, even when m is even, the remainder when 6 to the power m is divided by 5 is 1. Basically, irrespective of the fact that whether m is odd or even, 6 to the power m will always leave a remainder of 1 when divided by 5. 9 to the power n on the other hand, when n is odd, the remainder when 9 to the power n is divided by 5 is 4. When n is even, the remainder when 9 to the power n is divided by 5 is 1. So if you are adding 6 to the power m to 9 to the power n and you want a number which is a multiple of 5, you want only this case to happen and any one of this case is 5. That is, for this number to be a multiple of 5, we want n to be odd and m can be anything. The number of ways in which we can select n to be odd from 1, 2, 3, 4 dot 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 till 50 is 25. The number of values m can take is 50. M can be any number. So the total is 50 into 25, which is 1250. This is the value of P. Now what is the value of Q? For Q we need to calculate the number of elements in m and n such that m plus n is the square of a prime number. Now what are the prime numbers which are eligible? We have 2, the square of 2 is 4. We have 3, the square of 3 is 9. We have 5, the square of 5 is 25. We have 7, the square of 7 is 49. We also have the next prime number 11, the square of 11 is 121. But if you are selecting two numbers from 1 to 50, the sum of these two numbers, the maximum value of m plus n will be 50 plus 50, which is equal to 100. So you can't have m plus n to be equal to 121 or any number which is greater than 121. If m plus n is equal to 4, how many cases are possible? M can be 1, n can be 3, m can be 2, n can be 2, m can be 3 and n can be 1. So there are 3 cases that are possible. If m plus n is equal to 9, how many cases are possible? In the same way, 8 cases are possible, which is basically 9 minus 1. If m plus n is 25, again m can be 1 or 2 or dot 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 till 24. So the number of cases that are possible is 25 minus 1, which is 24 cases. And if m plus n is 49, the number of cases possible will be 48. The sum of all of them is 48 plus 24 is 72 plus 11 is 83. There are 83 cases possible. So the value of Q is 83. The value of P is 1250. What is the sum of P plus Q? P plus Q will be 1250 plus 83, which is equal to 1333. So the answer for this particular question will be 1333. In this question, we are required to calculate the number of ways in which 16 oranges can be distributed to 4 children such that each child gets at least 1 orange. Let us assume that the 4 children get A oranges, B oranges, C oranges and D oranges. The sum of A plus B plus C plus D is equal to 16 and all of them A, B, C and D is greater than or equal to 1. If all of them are greater than or equal to 1, let us assume that A is equal to A1 plus 1. Because A is greater than or equal to 1, A1 will be greater than or equal to 0. Let B be equal to B1 plus 1, C be equal to C1 plus 1 and D be equal to D1 plus 1. So the sum of all of them A plus B plus C plus D, which is equal to 16, is equal to A1 plus B1 plus C1 plus D1 plus 4, or the value of A1 plus B1 plus C1 plus D1 is equal to 12. How many solutions does this have? We know the formula for the number of non-negative integral solutions for a given equation. If you have an equation like x1 plus x2 plus x3 plus dot 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 plus xn is equal to r, the number of non-negative integral solutions for this, that is all of these variables are greater than or equal to 0, will be equal to n plus r minus 1 c n minus 1. In this particular case, it will be 12 plus 4 minus 1 c 4 minus 1. This is equal to 15 c3, which is equal to 15 into 14 into 13 divided by 6. 15 into 14 is 210, divided by 6 is 35. 35 into 13 is 455. So the answer for this particular question is option C, which is 455. In this question, we are told that there is group A, which consists of 7 boys and 3 girls, while group B consists of 6 boys and 5 girls. The number of ways in which 4 boys and 4 girls can be invited for a picnic if 5 of them must be from group A and the remaining from group B is equal to. So we have group A. This has 7 boys and 3 girls. And we have group B. This has 6 boys and 5 girls. Now we need to pick 5 people from group A and 3 people from group B. And we also need 4 boys and 4 girls. In how many ways can this be done? So let us assume that the number of boys in group B, because the total number of people from group B is 3, it can be either 3 boys and no girls, or it can be 2 boys and 1 girl, or it can be 1 boy and 2 girls, or it can be no boys and 3 girls. These are all the cases that are possible. If you look at the first case, where the number of boys selected from group B is 3, the number of boys selected from group A has to be 1, because the total number of boys is 4. If the number of girls selected is 0, the number of girls selected from group A has to be 4, because again we want the total number of girls to be 4. But that is not possible because in group A we have only 3 girls. So this case is not possible. What about the second case? If we have 2 boys from group B, we should have 2 boys from group A. If we have 1 girl from group B, we will have 3 girls from group A. This is one possibility. Similarly, in the next case, when we have 1 boy from group B, we will have 3 boys from group A. And we have 2 girls from group B, so we will have 2 girls from group A. And in the last case, when there are no boys from group B, we will need all the 4 boys from group A. And we have 3 girls from group B, so we will have 1 girl from group A. Now, how many ways can this be done? We need to select 2 boys from 7, so that can be done in 7C2 ways. We need to select 3 girls from 3, that can be done in 3C3 ways, which is basically 1. And we need to select 2 boys from 6, that can be done in 6C2 ways. And we need to select one girl from 5 that can be done in 5C one ways. This, if you simplify, is equal to 7C2 is 21 into 6C2 is 15 into 5C1 is 5. This is the first case. What about the second case? We need to select 3 boys from 7 that can be done in 7C3 ways. We need to select 2 girls from 3 that can be done in 3C2 ways. We need to select 1 boy from 6 that can be done in 6C1 ways. And we need to select 2 girls from 5 that can be done in 5C2 ways. This is equal to, what is 7C3? It is 35 into 3C2 is 3 into 6C1 is 6 into 5C2 is 10. What about the last case? We need to select 4 boys from 7 that can be done in 7C4 ways. We need to select 1 girl from 3 that can be done in 3C1 ways. We need to select no boys from 6 that can be done in 6C0 ways, which is basically 1. And we need to select 3 girls from 5 that can be done in 5C3 ways. This is equal to 7C4 is also 35 into 3 into 1 into 10. So the required answer is this plus this plus this, which is 21 into 15 into 5 plus 35 into 3 into 6 into 10 plus 35 into 3 into 1 into 10. All of them have 15 common, so just for the sake of making calculations easy, we'll take 15 common. 21 into 5 is 105. This is 35 into 3 into 4, which is 420. This is 35 into 2, which is 70. So this is equal to 15 into 420 plus 70 is 490 plus 105 is 595. This will equal 8925. So the answer for this particular question is option C, which is 8925. In this question, we are told that there is S, which is 1, 2, 3, 4, 5, 6, 7, and 8 and 9. X is the number of 9-digit numbers that can be formed using the digits of S, so that only one of the digits is repeated, and it is repeated exactly twice. So let us first try to calculate the value of X. In X, we basically have a 9-digit number. Now only one of the digits from 1 to 9 is repeated. Figuring out which that digit is can be done in 9 ways. The digit that is repeated can be either 1 or 2 or 3 or ... till 9. So that can be selected in 9 ways. Once that is selected, figuring out which of the 2 cells, which of the 2 places out of the 9 places that number will be repeated can be done in 9C 2 ways. For example, if you are assuming that the number which is repeated is 7, 7 can be picked in 9 ways. That is, it can be either 1 or 2 or 3 or ... till 9. Similarly, the 2 places where 7 actually comes can be selected in 9C 2 ways. For example, let us assume that this is one place for 7 and this is one place for 7. These 2 places can be selected in 9C 2 ways, which is 36 ways, 9 into 8 by 2. Once these 2 are selected, we have 7 places to fill, and they can be any number from 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 8 and 9. So this number can be selected in 8 ways. This number can be selected in 7 ways. This can be selected in 6 ways. This can be selected in 5 ways. This can be selected in 4, 3 and 2 ways. So the remaining numbers can be selected in 8 factorial ways. 9 into 8 factorial is 9 factorial. So the value of X is 36, which is the value of 9C2 into 9 factorial. What about Y? Y represents the number of 9-digit numbers that can be formed from the digits of the set S, so that 2 digits are repeated and each of them is repeated exactly twice. So let us try to calculate y. Again, let us draw 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now from the set S, we have to select 2 digits. They can be selected in 9C 2 ways, which is 36 ways. These are the 2 numbers which are going to be repeated. Let us assume that the 2 numbers that we select is say 3 and 8. The 2 numbers can be selected in 36 ways. For example, it can be 1 and 2 or 1 and 3 or 2 and 6. The total number of ways those 2 numbers can be selected is 36. For this example, for this explanation, let us assume that the 2 digits which are being repeated are 3 and 8. Now, we have to select 2 places for 3. That can be done in 9C 2 ways. Let us assume that this is one place for 3 and say this is another place for 3. The 2 places for 8 can be now selected in 7C 2 ways. So let us assume say this is 8 and this is 8. Now we have how many blanks remaining? 1, 2, 3, 4 and 5. And we have 7 numbers. Other than 3 and 8, there are 7 numbers remaining. So this blank can be filled in 7 ways, this in 6 ways, this in 5 ways, this in 4 and this in 3 ways. So basically the total number of ways will be 9C2. This is for selecting the 2 numbers 3 and 8 into 9C2. This is for selecting the 2 places for 3 into 7C2. This is for selecting the 2 places for 8 into 7 into 6 into 5 into 4 into 3. 9C2 is 36 into 36 into 7C2 is 21 into this is basically 7 factorial divided by 2, because we don't have a 2 at the end. 36 is 18 and you can cancel this. This is 9 into 4 into 18 is 9 into 2 into 21 into 7 factorial. This is basically the value of y. I have just expressed 36 as 9 into 4, 18 as 9 into 2, 21 is 21 and 7 factorial. The reason for that is because 4 into 2 is 8. Now if you are looking at 9 into 8 into 7 factorial, we are going to get 9 factorial. Into the remaining 2 is 9 into 21, which is 189. So the value of y is 9 factorial into 189. The value of x is 9 factorial into 36. So x divided by y is equal to 36 divided by 189, which is equal to 4 by 21. If you cross multiply, you are going to get 21x is equal to 4y. So the answer for this particular question is option D. In this question, we are told that there is a bag which contains 9 white balls and 8 black balls. So we have A, which has 9 white balls and 8 black balls. Similarly, we have a bag B. This consists of 6 white balls and 4 black balls. Now, one ball is randomly picked from bag B and mixed with the balls in bag A. That ball can be either white or it can be black. Then a ball is randomly picked from bag A. If the probability that the ball drawn is white is P by Q, what is the value of P plus Q? So let us assume the first case that the ball that is picked from B to A is white. The second case to consider is that the ball that is picked is black. If the ball that is picked is white, how many balls will be there in bag A? There will be 10 white balls and 8 black balls. And what is the probability that the ball picked is white? Out of the total of 10 balls, 6 is white and 4 is black. So the probability that this case exists is 6 by 10. And if this case exists, the probability of picking a white ball is 10 by 18. In the second case, when the black ball is picked, what is the probability that the ball that is picked is black? There are 4 black and 6 white balls. So that is 4 by 10. This is the probability that the ball that is picked is black. Once that is picked, we have 9 white balls and 9 black balls. So in this case, the probability of picking a white ball from bag A will be 9 by 18, which is 1 by 2. So the overall probability of picking a white ball will be 6 by 10 into 10 by 18 plus 4 by 10 into 9 by 18. You can cancel this, you can cancel this. This is 1 by 3 plus this is 1 by 2, this is 2, 1 by 5, which is equal to 8 by 15. So the required probability is 8 by 15. That is the value of P by Q. So P is equal to 8, Q is equal to 15. So the value of P plus Q is equal to 23. So the answer for this question is option A, which is 23. In this question, we are asked to calculate the number of ways in which 5 boys and 4 girls can sit in a row such that either all the boys sit together or no 2 boys sit together. There are 5 boys and 4 girls. So let us look at the first case in which all boys sit together. And let us look at the second case. No boy sits together. If you want all the boys to sit together, let the boys be B1, B2, B3, B4 and B5, and let the girls be G1, G2, G3 and G4. We want all the boys to sit together, so let us make them one entity. Let us call them B, and we have 4 girls. There is no restriction on the girls, they can arrange themselves. So now if you are looking at the entities, we have G1, G2, G3, G4 and B. These 5 entities can be arranged in 5 factorial ways. And the boys themselves, B1, B2, B3, B4, B5, amongst B, they can arrange themselves in 5 factorial ways. So the total number of ways in which the boys sit together is 5 factorial into 5 factorial. In the second case, if you don't want any of the boys to sit together, we have 5 boys, this is B. Let us assume that this is one boy, this is another boy, this is another boy, this is another boy and this is another boy. These are the 5 boys. We have just 4 girls and we need to have one girl between the first 2 boys, one girl between the second and the third boy, one girl between the third and the fourth boy and one girl between the fourth and the fifth boy. This is the only way in which no boy sits adjacent to another boy. Now the boys amongst themselves can be arranged in 5 factorial ways. That is, amongst these places where the boys are sitting, there are 5 spots and we have 5 boys. We can arrange the boys in 5 factorial ways. Similarly, we have 1, 2, 3, 4 spots for the girls and we have exactly 4 girls. They can be arranged in 4 factorial ways. So the total number of ways in which no boy sits adjacent to another boy is 5 factorial into 4 factorial. Overall, if you are looking at the total, it will be 5 factorial into 5 factorial plus 5 factorial into 4 factorial. 5 factorial we know is equal to 120. 4 factorial is equal to 24. So this is 120, you take common. 5 factorial is 120 plus 4 factorial is 24. This is 120 into 144. We know what is 12 into 144, it is 1728. So 120 into 144 is 17,280. So the answer for this question is 17280. In this question, we are told that there is a group in which there are 3 girls and 4 boys. Out of the 4 boys, 2 of them are B1 and B2. The number of ways in which these boys and girls can stand in a queue such that all the girls stand together, all the boys stand together, but B1 and B2 are not adjacent to each other. So let us assume that the three girls are G1, G2 and G3, and let the four boys be B1, B2, B3 and B4. Now all the three girls have to stand together, so let us call them as one entity G. Similarly, all the four boys have to stand together, so let us assume that this entity is called B. Now there are two possibilities, either G can be to the left of B or B can be to the left of G. So which one can be selected in two ways? So there are two cases. Once that is selected, let us assume that we are selecting the girls to be to the left of the boys. The number of ways in which the girls can arrange themselves, that is G1, G2, G3 or G3, G1, G2 or G2, G1, G3, those three girls amongst themselves, they can arrange themselves in 3 factorial ways. Once that is done, we need to arrange the boys, but in the boys we don't want B1 and B2 to stand adjacent to each other. So without that restriction, if there is no restriction that B1 and B2 cannot stand adjacent to each other, the number of ways in which we can arrange them is 24 ways, which is 4 factorial. But amongst those, there will be some cases in which B1 and B2 are adjacent to each other. How many such cases exist? Let us assume that B1 and B2, we call them together as say Bx. Now we have Bx and we have B3 and we have B4. Now these three entities can be arranged in 6 ways. Similarly, in Bx, we can have either B1 to the left of B2 or B2 to the left of B1. So that can be decided in 2 ways. Overall, the total number of ways or the total number of cases in which B1 and B2 are adjacent to each other is 6 into 2, which is 12 ways. So the number of cases in which they are not adjacent to each other is 4 factorial minus 12 ways. This is 2 into 6 into 4 factorial is 24, 24 minus 12 is 12. So the overall answer is 12 into 12, which is equal to 144. So the answer for this question is option B. In this question, we are looking for the number of 3-digit numbers that are divisible by 2 and 3, but they are not divisible by 4 and 9. So we are essentially looking for 2-digit numbers which are divisible by 6, but they are not divisible by 36. How many 3-digit numbers are divisible by 6? What is the smallest 3-digit number which is divisible by 6? The smallest 3-digit number which is divisible by 6 is 102. What is the largest 3-digit number which is divisible by 6? That is 996. So how many 3-digit numbers are divisible by 6? That will be 996, which is the last digit, minus 102 divided by 6 plus 1. This is 894 by 6 plus 1, which is 149 plus 1, which is 150. So the number of 3-digit numbers which are divisible by 6 is 150. Out of these 150 numbers, how many are divisible by 36? What is the smallest 3-digit number which is a multiple of 36? That is 108. What is the largest 3-digit number which is a multiple of 36? We can calculate it. It will be just 108 into 9 is 972. The next multiple of 36 will be 1008, which is a 4-digit number. So the largest 3-digit number which is a multiple of 36 is 972. So how many multiples of 36 are in 3 digits? That will be 972 minus 108 divided by 36 plus 1. This is equal to 864 divided by 36 plus 1. This is 24 plus 1, which is equal to 25. So the total number of multiples of 6 between 100 and 1000 is 150. Out of them, 25 are multiples of 36. Therefore, the number of multiples of 6 which are not multiples of 36 will be 150 minus 25, which is equal to 125. So the answer for this particular question is 125. 25. In this question, we are asked to calculate the largest value of n for which 40 to the power n divides 60 factorial. What is 40 to the power n? 40 is 8 into 5, which is 2 cube into 5. So 40 to the power n is equal to 2 to the power 3n into 5 to the power n. We know that if you are given a prime number p, what is the highest power of p which divides n factorial? This can be calculated. The highest power will be n divided by p, take the integer part out, plus n divided by p square, take the integer part out, plus n divided by p cube, take the integer part out, plus dot 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 dot. So the highest power of 2 in 60 factorial can be calculated. That will be 60 divided by 2 integer part plus 60 divided by 4 integer part plus 60 divided by 8 plus 60 divided by 16 plus 60 divided by 32. The next highest power of 2 is 64, which is greater than 60. So all the remaining values will be, the integer parts will be 0. 60 divided by 2 is 30, 60 divided by 4 is 15, 60 divided by 8 is 7.5, so the integer part is 7. 60 divided by 16 is 3.75, so the integer part is 3. 60 divided by 32, the integer part will be 1. The sum of all of them is 56. So the highest power of 2 in 60 factorial is 56. What is the highest power of 5? The highest power of 5 in 60 factorial will be 60 divided by 5, take the integer part out, plus 60 divided by 25, again take the integer part out. This is 12 plus 2, which is equal to 14. So the highest power of 5 in 60 factorial is 14, highest power of 2 is 56. We are required to calculate the highest power of 2 cube into 5. What we know is 2 to the power 56 into 5 to the power 14. This divides 60 factorial. What is the highest power of 2 to the power 3 into 5 that divides it? The answer will be 14. Why is that the case? Because 14 into 3 is 42. So you can write this as 2 to the power 14 into 2 to the power 42 into 5 to the power 14. This number divides 60 factorial. This is basically 2 cube into 5 whole to the power 14. Coincidentally, this is 2 to the power 14 into it, but basically the highest power of 2 cube into 5 is 14. So the answer for this question is option C, which is 14. If you are given this kind of a question, what you have to figure out is the highest power of both the primes. One of the prime has 2 cube in it. So in this case, 56 you divide by 3, 56 divided by 3 is 18.66. Why did you divide it by 3? Because that is the power of 3 in 40. The power of 5 in 40 is just 1 and we are getting 14. Amongst these two, whichever is lowest will be the answer. You again have to take the integer part out. For example, coincidentally, suppose the highest power of 2 is, instead of 56, suppose it is 35. In a different example, assume that. And the highest power of 5 is 14. Now if you are trying to calculate what is the highest power of 40, which divides this particular number, you divide 35 by 3. You are going to get 11.66. So the integer part is 11. For 5, it is 14. Which of these two is lesser? 11 is lesser. So in that hypothetical case, we would have said that the highest power of 40, which divides this given number, will be 11. But in this particular case, in this question, the power of 2 is 56. 56 divided by 3 is 18.66. That is greater than 14. We have to pick the lowest amongst the two, which is 14. So the answer for this question will be option C, which is 14. In this question, we are asked to calculate the number of 4-letter words with or without meaning that can be formed from PQR, PQR, STUV and P. So if you are looking at the number of times each letter is repeated, P is repeated 3 times. This is P, P and P. Q is repeated 2 times. This is Q, this is Q. R is repeated 2 times. This is R, this is R. And S, T, U and V is repeated only 1 time. We are required to form a letter. We are required to form a word which contains 4 letters. Now these 4 letters can be formed in multiple cases. One case is we have one letter which repeats 3 times and one letter which repeats only once. Or we can have 2 letters which are repeating 2 times each. Or we can have one letter which is repeating 2 times and the remaining 2 letters are distinct. Or we can have all the 4 letters to be independent. All the 4 letters to be distinct. Suppose we are looking at the first case. We want one of the letter to repeat 3 times and the next letter to be different. The letter which repeats 3 times has to be equal to P. This is the only letter which is repeated 3 times. And the other letter which is not P can be selected in 1, 2, 3, 4, 5 and 6 ways. So the number of ways in which we can select that one letter is 6. Now once that is selected, that letter which is repeated 3 times is P and the letter which is the 4th letter can be selected in 6 ways. The number of ways in which we can arrange them is 4 ways. What do I mean by it? What I am saying is, suppose P is repeated 3 times and the 4th letter that is selected, which can be selected in 6 ways, suppose we are assuming is S. Now P, 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 S, the number of arrangements that are possible amongst this P, 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 S is 4. We have to basically select a spot for S in the 4 letters. That is what we are saying over here. So the total number of cases possible over here is 24. Let us look at the next case. Suppose there is one letter which is selected 2 times and another letter which is selected 2 times. In how many ways can we form a 4-lettered word like that? Now the 2 letters which are being selected over here have to be 2 out of P, Q and R. They can be selected in 3C 2 ways. We are basically saying that can be either PQ or QR or PR. This is equal to 3 ways. Once they are selected, the number of ways in which we can arrange them will be equal to 6. For example, suppose the 2 letters that are selected are P and R. Each of them has to be repeated 2 times. So basically we will be having PP, RR. P is repeated 2 times, R is repeated 2 times. What is the total number of arrangements that are possible? The total number of arrangements that are possible will be 4 factorial divided by 2 factorial into 2 factorial, which is 6. So basically what we are saying is there are 3 ways to select the 2 letters. It is either PQ or QR or PR. Once they are selected, we can arrange them in 6 ways. So the total number of arrangements possible in this case will be 3 into 6, which is 18. Let us look at the next case. The next case is one letter is repeated 2 times and the remaining 2 letters are distinct. Now the letter which is repeated 2 times can be selected in 3 ways. That is either P or Q or R. Once that letter is selected, the remaining 2 letters can be selected out of the remaining 6 letters in 6C 2 ways. And once we have the 4 letters selected, that is the letter which repeats 2 times and the remaining 2 letters. Once we have selected these 3 letters, the total number of arrangements that are possible is 4 factorial divided by 2 factorial. This is equal to 2. So this will be, this is 3 into 15 into 12, which comes to equal 540. For example, what we are essentially saying is selecting the letter which is repeated 2 times can be done in 3 ways. Let us assume that is Q. It can be either P or Q or R. Once Q is selected, we have 6 letters remaining. We have P, R, S, T, U and V. Now amongst these 6 letters, we have to select 2 letters. That can be done in 62 ways, which is 15. Let us assume that the 2 letters which are selected are S and say V. These letters Q, Q, S, V can be arranged in 4 factorial divided by 2 factorial ways, which is 12. That is what we are saying. So the total arrangement is 3 into 15 into 12, which is 540. The last case is all the 4 letters are distinct. The total number of letters is P, Q, R, S, T, U and V. There are 7 letters. From the 7 letters, we have to select 4 letters. That can be selected in 7C 4 ways. Once that is done, we can arrange them in 4 factorial, which is 24 ways. So the total number of arrangements that are possible will be 7 into 6 into 5 divided by 6 into 24. This is 35 into 24, which is equal to 840. So the total number of 4 letter words with or without meaning that can be formed is 24 plus 18, which is equal to 42, plus 540, which is 582, plus 840. This will be equal to 582 plus 840. This is 2214. So that will be 1422. In this question, we are asked to calculate the largest value of n, where n is a natural number, such that 7 to the power n divides 101 factorial. We know that the highest power of a prime number p, which divides n factorial, is given by n divided by p, take the integer part out, plus n divided by p square, take the integer part out, plus continue doing it till the power of p is greater than n. In this particular case, the prime number is 7 and the natural number n is 101. So the highest power of 7, which divides 101 factorial, will be 101 divided by 7, take the integer part out, plus 101 divided by 49, take the integer part out, and the third term, which is 7 cube, is actually greater than 101. 7 cube is 343, so this becomes equal to 0 anyway, and all the future terms become equal to 0. 101 divided by 7 is 14 point something, so the integer part will be 14. 101 divided by 49 will be 2 point something, so the integer part is 2. So the highest power of 7, which divides 101 factorial, is 16, which is option D. In this question, we are asked to calculate the number of numbers greater than 5000 and less than 9000, which are divisible by 3, which can be found using the digits 0, 1, 2, 5 and 9. Now the number has to be greater than 5000 and less than 9000, so it is a 4-digit number. So let us write 4 blanks. This number has to be greater than 5000 and it has to be less than 9000. So the first digit cannot be 0 or 1 or 2. It cannot even be 9. So the first digit has to definitely be 5. If you are assuming that the second digit is A, third digit is B and fourth digit is C, the sum of all the digits in this number has to be a multiple of 3. Only then will this number be a multiple of 3. What is the remainder when 0 is divided by 3? The remainder is 0. What is the remainder when 1 is divided by 3? Again it is 1. When 2 is divided by 3, it is 2. When 5 is divided by 3, the remainder is 2. When 9 is divided by 3, the remainder is 0. So if you are looking at A plus B plus C, what should be the value of the remainder when A is divided by 3, plus when B is divided by 3, plus when C is divided by 3? So if you are looking at let us assume that this percentage is basically the remainder. the sum of the remainder when A is divided by 3 plus when B is divided by 3 plus when C is divided by 3, this has to be either equal to 1 because 5 leaves a remainder of 2 when divided by 3. So that overall the number is divisible by 3, or it has to be 4 because then it will be 2 plus 4, which is 6, again a multiple of 3. We can't expect the remainder when this to be equal to 7, because in that particular case that won't be possible because each of these remainders is either 0 or 1 or 2. So the maximum sum is 6. So basically we have to look at two cases. Either the remainder when A is divided by 3 plus the remainder when B is divided by 3 plus the remainder when C is divided by 3 is either 1 or it is equal to 4. If the remainder is 1, it would imply that the three remainders are 0, 0 and 1. That is the only possibility. And there is only one number which is leaving a remainder of 1 amongst these 5 numbers, that is 1 itself. So we have to select amongst these 3 where 1 will come. That can be selected in 3 ways. That is either A is 1 or B is 1 or C is 1. Once we have selected it, let us assume that B is equal to 1. So we have that number like this, we have 5 and 1. This number should leave a remainder of 0 when divided by 3. This number also should leave a remainder of 0 when divided by 3. So this number can be selected in 2 ways. It can be either 0 or 9. And the second number also can be selected in 2 ways. It can again be 0 or 9. So there are 12 cases possible. If the total sum of the 3 remainders is 1. If the sum of the 3 remainders is 4. Then there are 2 cases possible. Either we have 2 numbers which are leaving a remainder of 2 and 2 and the third number is leaving a remainder of 0, or we have one number which is leaving a remainder of 2 and the remaining 2 numbers are leaving a remainder of 1, because now the sum is 4. If we are looking at this particular case, there is only one number which is leaving a remainder of 1 and that is 1. So these two have to be 1. So out of these 3 spots, we have to select 2 spots for 1. That can be selected in 3 ways. So we have 5 over here and we have 3 blanks. Out of these 3 blanks, 2 of them have to be 1. That can be selected in 3 ways. Let us assume that these 2 are 1. Now this last remaining number has to leave a remainder of 2. So that number has to be either 2 or 5. So that can be selected in 2 ways. So there are 6 cases possible. If we are looking at the last case where there are 2 numbers which are leaving a remainder of 2 and one number which is leaving a remainder of 0, we have to fill the 3 blanks using these 3 numbers. Now figuring out which blank has a perfect multiple of 3, that is it is leaving a remainder of 0, can be decided in 3 ways. That is, we have the first number is 5. Amongst these 3 blanks, figuring out which blank has a multiple of 3 which is leaving a remainder of 0 can be selected in 3 ways. Let us assume that this is that number. So the remaining 2 have to leave a remainder of 2 each. Now the hundreds place, that is the number which is leaving a remainder of 2, can be selected in 2 ways. It can be either 2 or 5. This number which is leaving a remainder of 0 can be selected in 2 ways. It can be 0 or 9. And the last number which is again leaving a remainder of 2 can be again selected in 2 ways. It will be either 2 or 5. So this case has 3 into 2 into 2 into 2, which is 24 cases possible. So total is 24 plus 12 plus 6, which is equal to 42. So the total number of numbers possible is 42. In this question, this is an arithmetic progression. S of 40 is 1030, S of 12 is 57. We are required to calculate the value of S of 30 minus S of 10. If you have a arithmetic progression where the first term is A and the common difference is D, what is the sum of the first n terms? The sum of the first n terms will be n by 2 into 2A plus n minus 1 into D. So the value of the first 40 terms, S40, is equal to 40 by 2, which is 20, into 2A plus 39D. this is equal to 1030, or the value of 2a plus 39d is equal to 103 divided by 2. Similarly, S of 12 is 57. S of 12 is equal to 12 by 2, which is 6, into 2a plus 11d. This is equal to 57. Or this is 2, this is 19. 2a plus 11d is equal to 19 by 2. This is the first equation, this is the second equation. First equation minus the second equation, we are going to get 28d is equal to 103 by 2 minus 19 by 2, which is 84 by 2, which is equal to 42. Or the value of d is equal to 3 by 2. Once you have the value of d, we can calculate the value of a. We can substitute it in this particular equation. For example, 2a plus 33 by 2 is equal to 19 by 2. Or 2a is equal to minus 14 by 2, which is equal to minus 7. Or the value of a is minus 7 by 2. So we have the value of the first term, we have the value of the common difference. We are required to calculate S of 30 minus S of 10. What is S of 30? S of 30 is 15 times 2a plus 29d. This is equal to 30a plus, what is 29 into 15? It is 435d. What is S of 10? S of 10 is 5 times 2a plus 9d, which is equal to 10a plus 45d. So the difference between S of 30 minus S of 10 is 20a plus 390d. A is equal to minus 7 by 2. So 20a will be equal to minus 70. D is equal to 3 by 2. So 390d will be equal to 585. Therefore, this is equal to 515. So the answer for this particular question is option C, which is equal to 515. In this question, we are given an expression on the right hand side. This is 5 plus 1 by 7 into 5 plus alpha plus 1 by 7 square into 5 plus 2 alpha plus 1 by 7 cube into 5 plus 3 alpha plus dot 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 till infinity. We are required to calculate the value of alpha. If you are looking at the right hand side, this is basically the sum of two series. One is 5 plus 5 by 7 plus 5 by 7 square plus 5 by 7 cube and so on till infinity. This is a infinite geometric progression. The first term of the infinite geometric progression is 5 and the common ratio is 1 by 7. If you have an arithmetic progression like this, which is AR square and dot 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 till infinity, the sum of this geometric progression is A divided by 1 minus R. This is only valid if R lies between 1 and minus 1. In this particular case, the first term is 5 and the common ratio is 1 by 7. So the sum is equal to 5 divided by 1 minus 1 by 7, which is equal to 5 divided by 6 by 7. This is equal to 35 divided by 6. This is the first term. The second term is alpha. Let us call the second term to be S. The sum of the second term will be alpha by 7 plus 2 alpha by 7 square plus 3 alpha by 7 cube and so on. This is not a geometric progression, this is not an arithmetic progression. This is a arithmetic geometric progression because the numerators are in AP, the denominators are in GP. So for this, if you multiply the given sum with 1 by 7 and shift each term 1 to the right, what is alpha by 7 divided by 7? It is alpha by 7 square. What is 2 alpha by 7 square divided by 7? It is 2 alpha by 7 cube. And so on. Now if you subtract the equation from the earlier equation, s minus s by 7 is 6s by 7. This is equal to alpha by 7 plus 2 alpha by 7 square minus alpha by 7 square, which is alpha by 7 square, plus 3 alpha by 7 cube divided minus 2 alpha by 7 cube, which is alpha by 7 cube, and so on. The right hand side is again an infinite geometric progression where the first term is alpha by 7 and the common ratio is 1 by 7. So this is alpha by 7 divided by 1 minus 1 by 7, which is equal to alpha by 7 divided by 6 by 7. This is equal to alpha by 6. This is 6s by 7. So the value of s is equal to 7 alpha by 36. This is the sum of the second series. So the right hand side is equal to 35 by 6 plus 7 alpha by 36. So the given equation is 7 is equal to 35 by 6 plus 7 alpha by 36. We can simplify this. 7 minus 35 by 6 is 7 by 6 is equal to 7 alpha by 36. This and this gets cancelled. This will be equal to 6, or alpha is equal to 6. So the answer for this particular question is option B, which is alpha is equal to 6. Hi guys, so in this question we are given a geometric progression a1, a2 by 2, a3 by 2 square, dot dot dot, a10 by 2 to the power 9. The common ratio of this geometric progression is given, it is 1 by root 2. In addition to it, we are told that a1 plus a2 plus dot 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 till a10 is 62. We are required to calculate the value of a1. In a geometric progression, if the common ratio is given, the ratio of the consecutive terms is the common ratio. Here the first term is a1, the second term is a2 by 2. So a2 by 2 divided by a1 will be equal to the common ratio, which is 1 by root 2. Or a2 by 2a1 is equal to 1 by root 2. Or a2 is equal to a1 root 2. Similarly, if you look at the third term and the second term, we'll get the exact same thing. If you want, we can try it out. a3 divided by 2 square divided by a2 divided by 2 is equal to 1 by root 2. This would imply that a3 is equal to a2 by 2 into 1 by root 2 into 2 square, which is equal to a2 root 2. So if you are looking at the terms a1, a2, a3, a4, dot 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 till a10, a1 is equal to a1, which is fine, a2 is equal to a1 root 2, a3 is equal to a2 root 2, so that will be equal to 2 times a1, a4 will be equal to a1 into 2 root 2, so this also is a geometric progression. The common ratio is equal to root 2 and the 10th term a10 will be equal to a1 into root 2 to the power 9. The sum of all of them, we are told, is equal to 62. If you have a geometric progression where the first term is a and the common ratio is ar and the common ratio is r, what is the sum of the first n terms? The sum of the first n terms of a geometric progression is equal to a into r to the power n minus 1 divided by r minus 1. In this particular case, the sum of a1 plus a1 root 2 plus 2a1 plus dot 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 plus a1 into root 2 to the power 9. This is a geometric progression. The first term is a1. The common ratio is root 2. The number of terms is 10 minus 1 divided by root 2 minus 1. This is equal to a1 into what is square root of 2 to the power 10? That will be equal to 2 to the power 5, which is 32 minus 1 divided by root 2 minus 1. or this is equal to 31 times a1 divided by root 2 minus 1. This we are told is equal to 62. So this is equal to 62, or the value of a1 is equal to 2 times root 2 minus 1. So the answer for this question is option C, 2 times root 2 minus 1. In this question, we are given a quadratic equation. This is 3x square minus px plus q is equal to 0. And we are told that the two roots of this quadratic equation are the 10th and the 11th terms of an arithmetic progression with common difference 3 by 2. The sum of the first 11 terms of this arithmetic progression is 88. Let us assume that for this arithmetic progression, the first term is a. The common difference d is given, this is 3 by 2. What is the sum of the first n terms of an arithmetic progression? It will be n by 2 into 2a plus n minus 1 into d. We are told that the sum of the first 11 terms is 88. So 11 by 2 into 2a plus 10d is equal to 88. 88 divided by 11 is 8. 2a plus 10d divided by 2 is a plus 5d. So a plus 5d is equal to 8. We know the value of d. This is 3 by 2. So a plus 15 by 2 is equal to 8, or the value of a is 1 by 2. So a is equal to 1 by 2. Now we are required to calculate the 10th term and the 11th term. In an arithmetic progression, this is the sum of the first n terms. What is the nth term? Nth term is a plus n minus 1 into d. So what is the 10th term? 10th term is a plus 9d, which is equal to 1 by 2 plus 9 into 3 by 2. This is 27 by 2 plus 1 by 2, which is 14. What is the 11th term? 11th term is a plus 10d. This is equal to 1 by 2 plus 10 into 3 by 2, which is equal to 31 by 2. So the two roots of the given quadratic equation are 14 and 31 by 2. Those are the two roots. Now we know that in any quadratic equation which is of the form ax square plus bx plus c is equal to 0, sum of roots is equal to minus b by a. Product of roots is equal to c by a. In this particular case, the sum of the roots is p by 3. So p by 3 is the sum of both of them, which is equal to 14 plus 31 by 2, which is equal to 59 by 2. That is the value of p by 3, or the value of p is equal to 177 by 2. Product of the roots is c by a. What is the product of the roots? That will be q by 3. So q by 3 is equal to 31 by 2 into 14, which is 270. This is q by 3, so the value of q is 651. This is q, this is p. What are we required to calculate? We are required to calculate q minus 2p. So q minus 2p will be 651 minus 2 times 177 by 2, which is 651 minus 177. This is equal to, this is 474. So the answer for this question is 474. In this question, we are told that the sum of the first 4 terms of an arithmetic progression is 6, and the sum of the first 6 terms is 4. We are asked to calculate the sum of the first 12 terms. In an arithmetic progression where the first term is a and the common difference is d, the terms will be of the form a plus d, a plus 2d, and so on. And what is the sum of the first n terms of an arithmetic progression? It is n by 2 into 2a plus n minus 1 into d. Here if you assume that for this arithmetic progression, the first term is a and the common difference is d, what is the sum of the first four terms? That will be 4 by 2 into 2a plus 4 minus 1, that is 3d. This we are told is equal to 6. 4 by 2 is 2. This would imply that 2a plus 3d is equal to 3. And the sum of the first 6 terms is 4. What is the sum of the first 6 terms? That will be 6 by 2 into 2a plus 6 minus 1, which is 5d. This is equal to 4. This is equal to 3, or 2a plus 5d is equal to 4 by 3. This is the first equation. This is the second equation. If you subtract the first equation from the second equation, you are going to get 2d is equal to 4 by 3 minus 3. This is equal to minus 5 by 3. Or the value of d is equal to minus 5 by 6. Now, what is the value of 2a then? 2a plus 3d, this will be minus 5 by 2, is equal to 3, or 2a is equal to 3 plus 5 by 2, which is equal to 11 by 2. So the value of a is 11 by 4. So the first term is 11 by 4, the common difference is minus 5 by 6. We are required to calculate the sum of the first 12 terms. So sum of the first 12 terms will be 12 by 2 into 2a plus 11d. This is 6. So this will be 6 into 2 times 11 by 4 is 11 by 2, plus 11 times minus 5 by 6 is minus 55 by 6. This is equal to 33 minus 55, which is equal to minus 22. So the answer for this particular question is equal to option A, which is equal to minus 22. In this question, we are given a summation. We are told that s is equal to 1 by 25 factorial plus 1 by 3 factorial into 23 factorial plus 1 by 5 factorial into 21 factorial dot 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 till 13 terms. We are told that 13 times s is equal to 2 to the power k divided by n factorial. K is a natural number. We are required to calculate the value of n plus k. If you are looking at the terms, this is 25 factorial, this is 3 factorial into 23 factorial. The sum of 3 plus 23 is 26. Here also we have 5 factorial into 21 factorial. 5 plus 21 is 26. So immediately you should understand that this is part of a binomial expansion. So if you multiply s with 26 factorial, you are going to get 26 factorial divided by 25 factorial. Just because all the denominators have 2 terms, we can write this as 1 factorial into 25 factorial plus 26 factorial divided by 3 factorial into 23 factorial plus 26 factorial divided by 5 factorial into 21 factorial plus dot 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 dot. The 13th term will be 26 factorial divided by 25 factorial into 1 factorial. This is the sum of the odd terms of a binomial expansion. That is, this is equal to 26c1 plus 26c3 plus 26c5 plus dot 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 plus 26c25. In a binomial expansion, these are all the odd terms. We know that 26c0 plus 26c1 plus dot 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 26c24 plus 26c25 plus 26c26 is equal to 2 to the power 26. This is known. This is sum of all the terms of the binomial expansion which has 26, the power is 26. This will be equal to 2 to the power 26. But if you are looking only at odd terms, like in this particular case, one thing you have to remember is sum of the odd terms is equal to the sum of the even terms. That is 26c0 plus 26c2 plus 26c4 plus dot 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 plus 26c24 plus 26c 26. These are all the even terms. This sum is equal to sum of all the odd terms, which is 26c1 plus 26c3 plus dot 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 plus 26c25. The sum of all the terms is equal to 2 to the power 26. The sum of odd terms, which is equal to the sum of even terms, this will be equal to 2 to the power 25. So what we have over here is 26 factorial into s is equal to 2 to the power 25. Now if you are looking at the expression that is given, we have 13s over here. So we will express this as 26 into 25 factorial. 26 into 25 factorial is nothing but 26 factorial into s is equal to 2 to the power 25. So this is 13 and this will be 2 to the power 24. We are just dividing the left hand side and right hand side with 2. So we are going to get 13s is equal to 2 to the power 24 divided by 25 factorial. This is exactly what we have over here. So k will be equal to 24 and n will be equal to 25. And the sum of both of them is equal to 49. So the answer for this particular question is option C, which is equal to 49. In this question, we are told that a1, a2 dot 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 is a geometric progression with increasing positive terms. a1 into a5 is 28, a2 into a4 is 29. We are required to calculate a6. In a geometric progression, if the first term is a and the common ratio is r, then the terms will be ar square dot 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 dot. The rth term will be equal to a into the nth term will be equal to a into r to the power n minus 1. So the value of a5 is equal to a1 into r to the power 4. The value of a2 is equal to a1r. The value of a4 is equal to a1 into r cube. Now the product of the first term and the fifth term is 28. So a1 into a1 r to the power 4 is equal to 28. This would imply that a1 square into r to the power 4 is 28. a2 plus a4 is 29. What is a2? a2 is a1r plus a4 is a1r cube. This is equal to 29. If you are looking at these two terms, if you assume for example that a1r is equal to x and a1r cube is equal to y, what is the product of both of them? The product of both of them will be a1 square r to the power 4. This is equal to x into y. Why did I write it like that? Because a1 square r to the power 4 is equal to 28. So essentially what we have is two terms such that x plus y is equal to 29 and x into y is equal to 28. Here you can immediately guess that one of them has to be 1 and the other one has to be 28. If you are not able to guess that, you can figure out or substitute the value of y to be equal to 28 by x. So this given equation will become equal to x plus 28 by x is equal to 29, or x square minus 29x plus 28 is equal to 0. This is a quadratic equation of the form x minus 1 into x minus 28 is equal to 0. So either x is 1 or x is equal to 28. If x is 1, y will be 28. If x is 28, y is 1. But one thing we should be clear is that we are told that this is an increasing geometric progression. So the fourth term has to be greater than the second term. So a1 r is equal to 1, a1 r cube is equal to 28. The ratio of both of them will be r square. this is equal to 28. I'm just dividing the second equation by the first equation. So r square is equal to 28. What are we required to calculate? We are required to calculate the value of a6. a6 will be equal to a1 r to the power 5. Now we know a1 r cube, this is 28. So a1 r to the power 5 is a1 r cube into r square. a1 r cube, this is 28, and r square, this also is 28. So the sixth term is 28 square, which is 784. So the answer for this question is option D. In this question, we are given a infinite series 1 by 3 plus 4 by 7, 1 by 3 square plus 1 by 3 into 4 by 7 plus 4 by 7 whole square, 1 by 3 whole cube plus 1 by 3 square plus 4 by 7 plus 1 by 3 plus 4 by 7 square plus 4 by 3 4 by 7 whole cube. Even though it sounds complex, if you assume that a is equal to 1 by 3 and b is equal to 4 by 7, and if you assume that the sum is equal to s will be equal to a plus b plus a square plus ab plus b square plus a cube plus a square b plus ab square plus b cube plus dot till infinite terms. Whenever you see this kind of a equation, one of the first things that you should think of is multiplying both sides with a minus b. Because a plus b into a minus b is a square minus b square. A square plus ab plus b square into a minus b is a cube plus a cube minus b cube. A cube plus a square b plus ab square plus b cube into a minus b is a to the power 4 minus b to the power 4 plus dot till infinity. Now the right hand side is much simpler. This is equal to a square plus a cube plus a to the power 4 plus dot till infinity minus b square minus b cube minus b to the power 4 minus dot till infinity. This is an infinite geometric progression. This is an infinite geometric progression. We know the sum of an infinite geometric progression. If you have an infinite geometric progression which is of the form ar square, ar cube, dot till infinity, the sum of this infinite geometric progression is a divided by 1 minus r. This is true if r lies between minus 1 and 1. So a square plus a cube plus a to the power 4 plus dot till infinity, that sum is equal to a square divided by 1 minus a, and this is minus of b square by 1 minus a. This is the value of s into a minus b. What is the value of a? A is equal to 1 by 3. What is the value of b? B is equal to 4 by 7. So what is a minus b? A minus b is 1 by 3 minus 4 by 7, which is equal to minus 5 by 21. So minus 5 by 21 into s is equal to a square by 1 minus a. What is a square by 1 minus a? This is 1 by 9 divided by 2 by 3, which is equal to 1 by 6. So this is equal to 1 by 6 minus, this is b square by 1 minus b. Because in the second progression, the first term is b square and the common ratio is b. So it will be b square divided by 1 minus b. What is b square by 1 minus b? B is equal to 4 by 7. So this is 16 by 49 divided by 1 minus 4 by 7, which is 3 by 7, which is equal to 16 by 21. So this will be 1 by 6 minus 16 by 21. This would imply that minus 5 by 21 into s is equal to divided by 42, 7 minus 32, or minus 5 by 21s is equal to minus 25 by 42. this is 2, this is plus, and this is 5. Or the value of S is equal to 5 by 2. So the answer for this particular question is equal to option C, which is equal to 5 by 2. In this question, we are told that the number of terms in an arithmetic progression is 2k, so they are even number of terms. The sum of all the odd terms is 40, and the sum of all the even terms is 55. The last term of the arithmetic progression exceeds the first term by 27. We are required to calculate the value of k. Let us assume that the terms of the arithmetic progression are a1, a2, a3, a4, till a of 2k. So what are all the odd terms? The odd terms will be a1 plus a3 plus a5 plus a7 plus till plus a of 2k minus 1. This we are told is 40. The sum of the odd terms is given as 40. What are all the even terms? The even terms is a2 plus a4 plus a6 plus a8 plus plus a of 2k. This we are told is 55. The sum of all the even terms is given. This is equal to 55. Now if you subtract the first equation from the second equation, what is a2 minus a1? a2 minus a1 is equal to d. If you assume that for this arithmetic progression the common difference is d, a2 minus a1 is d. Similarly, a4 minus a3 is also equal to d. Similarly, a6 minus a5 is also equal to d, and so on. Even a2k minus 1 is also equal to d. This is equal to 15. How many times does this repeat? This repeats exactly k times. So the value of d into k is equal to 15. We are given one additional piece of information. We are told that the last term of the AP exceeds the first term by 27. What is the last term? The last term is a2k, which is equal to a1 plus 2k minus 1 into d. This minus a1 will be simply equal to 2k minus 1 into d. This is the difference between the last term and the first term. This we are told is equal to 27. So we have this equation and we have this equation. If you divide the second equation by the first equation, we are going to get 2k minus 1 divided by k is equal to 27 divided by 15, which is equal to 9 by 5. We can cross multiply. We are going to get 10k minus 5 is equal to 9k, or the value of k is equal to 5. We are required to calculate the value of k, so it will be equal to 5. In this question, we are told that there is a geometric progression. The product of the first three terms is 27, and the set of all the possible values for the sum of the first three terms is all the real numbers except within the range of a and b. We are required to calculate a square plus b square. This is a geometric progression, so let us assume that the terms are a, ar square, and so on. The product of the first three terms, that is the product of these three terms, is 27. So a into ar square is equal to 27, or a cube r cube is equal to 27, or a into r is equal to 3. If a into r is equal to 3, the second term essentially is equal to 3. So the first term is 3 divided by r, second term is 3, third term is 3r, and so on. Now what is the sum of the first three terms? The sum of the first three terms is 3 plus 3 by r plus 3r, which is equal to 3 plus 3 times r plus 1 by r. Now what do we know about r plus 1 by r? If r is positive, this is always greater than or equal to 2. r plus 1 by r, we can prove from the arithmetic mean is greater than or equal to geometric mean that it is always greater than or equal to 2. If r is negative, this is always less than or equal to minus 2. That is what we know about r plus 1 by r for any value of r. So if r is positive, this expression is greater than or equal to 3 plus 3 into 2, which is equal to 9. If r is negative, this expression will be less than or equal to 3 minus 3 into 2, which is equal to minus 3. So the sum of the first three terms can take all the values in real systems, all the real numbers, except the numbers between minus 3 and 9. So the value of A is minus 3, the value of B is 9. So the sum of A square is 9, sum of B square is 81, sum of both of them is equal to 90. So the answer for this particular question is 90. In this question, the common difference of the arithmetic progression a1, a2 dot 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 till am is 13 more than the common difference of another progression b1, b2 dot 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 till bn. b31 is given as minus 277, b43 is given as minus 385. What is the first term has to be calculated, a78 is given as 327. If you are given a arithmetic progression which is of the form a plus d, a plus 2d and so on, where the first term is equal to a and the common difference is d, the nth term is equal to a plus n minus 1 into d. If you are looking at the second arithmetic progression, b31 is minus 277. So, if you are assuming that the first term is b1, this is b1 plus 30d2 is equal to minus 277. We are assuming that the common difference of the first arithmetic progression is d1 and the common difference of the second arithmetic progression is d2. So if the 31st term is minus 277, b1 plus 30 times d2 is minus 277. Similarly, the 43rd term is minus 385. So this is b1 plus 42 d2 is equal to minus 385. You subtract the first equation from the second equation. You are going to get 12d2 is equal to minus 385 minus of minus 277, which is minus 108. Or the value of d2 is equal to minus 9. So this would imply that the common difference of the second arithmetic progression is minus 9. The common difference of the first arithmetic progression is 13 more than that. So it is 13 more than minus 9. So this will be equal to 4. And the 78th term of that arithmetic progression is 327. So a1 plus 77 times d1 is equal to 327. But we know, we just discussed that d1 is equal to 4. So a1 plus 77 into 4 is equal to 327. 77 into 4 is 308. So a1 is equal to 19. So the answer for this particular question, where the first term of the first arithmetic progression has to be calculated, is option C, which is equal to 19. In this question, we are told that there is an arithmetic progression of positive integers. The sum of the first three terms is 54 and the sum of the first 20 terms lies between 1600 and 1800. We are required to calculate the 11th term. Whenever you are given that the sum of the first 15 term, whenever you are given that the sum of the first three terms is 54, I would want to write the three terms as this is the first term, which is a, the second term, which is a plus d, and the third term, which is a plus 2d. The sum of these three is equal to 54. So this is 3a plus 3d is equal to 54. If you divide this equation with 3, we are going to get a plus d is equal to 18. So the middle term is equal to 18. The first term will be 18 minus d, the second term is 18 and the third term is 18 plus d. The sum of these three terms is equal to 54. Now, what is the sum of the first 20 terms? We know that the sum of the first 20 terms in a arithmetic progression is given by the formula n by 2 into 2a plus n minus 1 into d. So the sum of the first 20 terms is equal to 10 into 2a plus 19d. Here the first term a is equal to 18 minus d. So this is equal to 10 into 36 minus 2d plus 19d, or this is 10 times 36 plus 17d. This we are told lies between 1600 and 1800. So this is greater than 1600, this is less than 1800. If you divide this entire equation with 10, or if you divide this entire inequality with 10, we are going to get 160 is less than 36 plus 17d is less than 180. If you subtract 36 from all the terms of this inequality, we are going to get 124 is less than 17d is less than 144. Now we are told that all the terms of this given arithmetic progression are integers. So d has to be an integer. So 17d will be a multiple of 17. What is the only multiple of 17 between 124 and 144? 17 into 7 is 119. 17 into 8 is 136. 17 into 9 is 153. The only multiple of 17 between 124 and 144 is 136. So 17d has to equal 136, or the value of d is equal to 8. So what is the first term? First term of the arithmetic progression is 18 minus d. So a is equal to 10, d is equal to 8. We are required to calculate the 11th term, which is equal to the first term plus 11 minus 1, which is 10 into d. This is equal to 90. So the 11th term of this given arithmetic progression will be equal to 90, which is option A. In this question, we are told that S of n is 1 by 2 plus 1 by 6 plus 1 by 12 plus 1 by 20 dot 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 till n terms. We are told that the sum of the first 6 terms of an arithmetic progression, where the first term is minus p and the common difference is p, is square root of 2026 into S 2025. The absolute difference between the 20th term and the 50th term of the AP is needed. Let us first calculate the value of S of 2025. Whenever you are given a series of this form, which is 1 by 2 plus 1 by 6 plus 1 by 12 plus 1 by 20 plus dot dot dot, if you are looking at the denominators, 2 is 1 into 2, 6 is 2 into 3, 12 is 3 into 4, 20 is 4 into 5, and so on. So this sum S of 2025 is equal to 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by 3 into 4 plus 1 divided by 4 into 5 plus dot 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 dot. What is 1 divided by 1 into 2? This is actually equal to 1 by 1 minus 1 by 2. 1 divided by 1 into 2 is 1 by 1 minus 1 by 2, and 1 by 2 into 3, which is equal to 1 by 6, can be written as 1 by 2 minus 1 by 3, and 1 by 3 into 4 can be written as 1 by 3 minus 1 by 4, and 1 by 4 into 5 can be written as 1 by 4 minus 1 by 5, and so on. If you are continuing to add them and you are having 2025 terms, you will notice that the second term of the first two terms and the first term of the second pair are the same. This is minus 1 by 3, this is 1 by 3, this is minus 1 by 4, this is 1 by 4, and so on. Finally, we are left with 1 minus 1 divided by 2026, which is equal to 2025 divided by 2026. This is the value of S of 2025. So what is the value of 2026 into S of 2025? This is simply equal to 2025. And the square root of this, which is what is given in the question, is equal to square root of 2025, which is equal to 45. But what exactly is this? This is the sum of the first 6 terms of the arithmetic progression. If you have an arithmetic progression where the first term is a and the common difference is d, the sum of the first n terms is given by n by 2 into 2a plus n minus 1 into d. Here the first term is minus p. The common difference is p. And we are asked to calculate the sum of the first 6 terms. So s of 6 is equal to 3 times minus 2p plus 5p. This is equal to 9p. This is the sum of the first 6 terms of the arithmetic progression, that is equal to 45. So 9p is equal to 45, or the value of p is equal to 5. Now what are we required to calculate? We are required to calculate the absolute difference between the 20th and the 15th term of the AP. Now what is the nth term of an arithmetic progression? The nth term of an arithmetic progression is a plus n minus 1 into d. So the 20th term is a plus 19d, and the 15th term is a plus 14d. The difference between both of them is 5d, but the common difference d is given to be equal to p, so this is equal to 5p. The value of p is 5, so 5p will be equal to 25. So the answer for this particular question is option D, which is equal to 25. In this question, we are asked to calculate the value of square root of 3 into cosecant 20 minus secant 20 divided by cos 20, cos 40, cos 60, cos 80. So let us first look at the numerator, calculate its value, then look at the denominator and calculate its value. If you are looking at the numerator, this is equal to root 3 cosecant 20, so that is root 3 by sin 20 minus 1 by cos 20. This is equal to root 3 into cos 20 minus sin 20 divided by sin 20 cos 20. Now the numerator is looking similar to sin A minus B. How do I do it? Suppose I multiply the numerator with 2 and divide it with 2. So the numerator becomes equal to 2 into root 3 by 2 cos 20 minus 1 by 2 sin 20. Basically I want to convert this root 3 into root 3 by 2 because that is the value of sin 60, divided by the numerator is sin 20 into cos 20. Now I know that root 3 by 2 is equal to sin 60 and 1 by 2 is equal to cos 60. So this is of the form 2 into sin 60 cos 20 minus cos 60 sin 20 divided by sin 20 cos 20. Now what is this looking like? This is sine of 60 minus 20. Why is that the case? Because we know the formula for sine of A minus B. Sine of A minus B is sine A cos B minus cos A sin B. So this is equal to sine of A minus B. So this is, the numerator is 2 times sine of 60 minus 20, which is 40, divided by sin 20 cos 20. Now whenever I have sin A into cos A, something like when the angle is the same, I always think of sin 2A because we know the formula for sin 2A. What is the formula for sin 2A? This is 2 times sin A into cos A. So if I am looking at sin 40 as 2 times sin 20 into cos 20, this becomes equal to 2 into 2 times sin 20 into cos 20 divided by sin 20 cos 20. I can cancel these two, I can cancel these two. This is equal to 4. So the value of the numerator, this is equal to 4. Now let us look at the denominator. Denominator is cos 20, cos 40, cos 60, cos 80. So if I am looking at the denominator, this is equal to cos 20 into cos 40 into cos 60 into cos 80. Now I can write cos 80 as sin 10 because we know that cos of theta is equal to sine of 90 minus theta. So this will be equal to sine 10. Sine 10 is just equal to cos 80. So this is sine 10 into cos 20 into cos 40 into cos 60. Why did I write it as sine 10? Because I want to again use the formula for sine 2a. So for example, here I will multiply the numerator and denominator with 2 times cos 10. So this is 2 times cos 10 divided by 2 times cos 10, both of them cancel each other, into sine 10 into cos 20 into cos 40. And what is the value of cos 60? Cos 60 is 1 by 2. This is important because 2 times sine 10 into cos 10 is equal to sine 20. This is the formula for sine 2a, which is 2 times sine a into cos a. So this is equal to sine 20 divided by 2 cos 10 into cos 20 into cos 40 into 1 by 2. Now what is sine 20 into cos 20? This is again of the form sine 2a, which is equal to 2 times sine a into cos a. So this is equal to 1 by 2 into sine 40. So this is 1 by 2 into sine 40. 1 by 2 into sine 40 is sine 20 into cos 20 divided by 2 times cos 10 into cos 40 into 1 by 2. Again I am looking at sine 40 into cos 40. Again this is of the form sine 2a, which is equal to 2 times sine a into cos a. So again this will be equal to 1 by 2 into 1 by 2 into sine 80 divided by 2 times cos 10 into 1 by 2. Now sine 80 is equal to cos 10. Remember the formula that we discussed? Cos of 90 is equal to sine of 90 minus theta. So cos 10 will be equal to sine 80. And this is basically equal to 1 by 16. This is the value of the denominator. So the denominator, this is equal to 1 by 16. So the required answer is just 4 divided by 1 by 16, which is equal to 64. So the answer for this question is option D, which is equal to 64. In this question, we are asked to calculate the value of cosecant 10 degrees minus square root of 3 secant 10 degrees. We know that cosecant of theta is 1 by sin theta and secant of theta is 1 by cos theta. So this expression can be simplified to equal 1 by sin 10 degrees minus root 3 divided by cos 10 degrees. If you are taking the same denominator, this is equal to cos of 10 degrees minus root 3 of sin 10 degrees divided by sin 10 degrees into cos 10 degrees. Now we should immediately, whenever we say root 3, we should think of sin 60 degrees or cos 30 degrees. So let us divide the numerator by 1 by 2 and multiply the entire expression with 2. So essentially we are saying that this is equal to 2 into 1 by 2 times cos 10 degrees minus root 3 by 2 times sin 10 degrees divided by the same denominator, which is sin 10 into cos 10 degrees. Now what do we know about 1 by 2? Sin 30 degrees is equal to 1 by 2. And what is cos 30 degrees? Cos 30 degrees is root 3 by 2. This is 1 by 2 here and this is root 3 by 2. So the given expression is simply equal to 2 times sin 30 into cos 10 minus cos 30 into sin 10. Divide this entire equation with sin 10 into cos 10. Now the numerator is of the form sin A cos B minus cos A sin B. So that is sin of A minus B. So this is equal to 2 times sin of 20 degrees divided by this denominator is sin 10 into cos 10. Now what do we know about sin 2A? We know the formula that sin 2A is equal to 2 times sin A cos A. So sin 20 degrees is 2 times sin 10 into cos 10. So this is simply equal to another 2, which is equal to 4. So the answer for this particular question will be option A, which is equal to 4. We are given an equation in cos theta and we are required to calculate the number of values of theta between minus 3 pi and 2 pi which satisfy this given equation. We are given cos 2 theta at the start and we know that cos 2 theta is equal to 2 times cos square theta minus 1. So the given expression is root 3 times 2 cos square theta minus 1 plus 8 cos theta plus 3 root 3 is equal to 0. If you are simplifying it, it is 2 root 3 times cos square theta minus root 3 plus 8 cos theta plus 3 root 3 is equal to 0. This is minus root 3, this is plus 3 root 3, so this is plus 2 square root of 3. So the given quadratic equation is 2 root 3 cos square theta plus 8 cos theta plus 2 root 3 is equal to 0. We can divide this entire equation with 2. We are going to get root 3 cos square theta plus 4 cos theta plus root 3 is equal to 0. We can simplify this as root 3 cos square theta plus 3 cos theta plus cos theta plus root 3 is equal to 0. We can simplify this to equal root 3 cos theta plus 1 into cos theta plus 3 plus root 3 is equal to 0. So the value of cos theta is either equal to minus 1 by root 3 or minus square root of 3. Now one thing we know is cos theta lies between minus 1 and plus 1. So this is not true. So the value of cos theta is minus 1 by root 3. If you are told that theta is an angle which lies between say 0 and 2 pi, what are the values or what are the quadrants that cos theta can actually be in? So if you are drawing the y-axis and the x-axis, over here cos theta lies between 0 and 1. In the second quadrant, cos theta will lie between 0 and minus 1. So here we are going to get one value of cos theta because the value of cos theta is minus 1 by root 3. In the third quadrant also cos theta lies between 0 and minus 1. So again here we are going to get another value because cos theta is negative. In the fourth quadrant cos theta is positive. So 0 will lie between cos theta and 1. So if you are looking at 0 to 2 pi, we will get two values for theta. If you are looking at minus 3 pi to 0, we are going to get two values here and we are going to get one more value over here. So between minus 3 pi and 0, we will get three values. So overall between minus 3 pi and 2 pi, the total number of values we will get for theta will be equal to 5. So the answer for this question is option B, which is 5. In this question, we are told that we are given a expression and we are told that alpha and beta are the maximum and minimum values of the given expression. Let us try to simplify the expression. The one thing that you should know is that sine of pi by 2 minus theta is equal to cos theta. And what is the value of sine of pi minus theta? This will be sine theta. Similarly, it will be the same for even cos. That is, cos of pi by 2 minus theta will be sine theta, and cos of pi minus theta will be minus cos theta. But because here the powers of sine are all even numbers, we don't have to particularly worry about whether it is minus sine theta or plus sine theta. So from the first expression, which is sine to the power 4 into 7 pi by 2 minus theta is equal to cos to the power 4 theta. Similarly, the second term, which is sine of to the power 4 11 pi plus theta is equal to sine to the power 4 theta. We have sine to the power 6 into 3 pi by 2 minus theta. This is equal to cos to the power 6 theta. And here we have sine to the power 6 into 9 pi minus theta. This will be equal to sine to the power 6 theta. So the expression that is given to us is 4 times cos to the power 4 theta plus sine to the power 4 theta minus 2 times cos to the power 6 theta plus sine to the power 6 theta. One thing we know about a cube plus b cube is that this is equal to a plus b into a square minus ab plus b square. Here we have cos to the power 6 theta plus sine to the power 6 theta. So if you assume that a is cos square and b is sine square, this part can be simplified to equal cos square theta plus sine square theta. This is basically a plus b into a square minus ab plus b square. So that will be into cos to the power 4 theta minus sine square theta cos square theta plus sine to the power 4 theta. This is just the value of the term cos to the power 6 theta plus sine to the power 6 theta. So this is minus 2 times this. This is the second part of the expression. The first part is 4 cos to the power 4 theta plus sine to the power 4 theta. This is the value of the expression. As we know, cos square theta plus sine square theta is equal to 1. So when you are simplifying, the expression is equal to 4 cos to the power 4 theta plus 4 sine to the power 4 theta minus 2 cos to the power 4 theta plus 2 sine square theta cos square theta minus 2 sine to the power 4 theta. This can be simplified to equal 2 times cos to the power 4 theta plus sine square theta cos square theta plus sine to the power 4 theta. This is equal to 2 times cos square theta plus sine square theta whole square minus cos square theta sine square theta. This is the simplified value of the same expression. Again, we know cos square theta plus sine square theta is equal to 1. So this expression can be simplified to equal 2 minus 2 times sine square theta cos square theta. This is equal to 2 times 2 minus, what do we know about sine 2 theta? Sine 2 theta is 2 times sine theta cos theta. So sine square 2 theta will be equal to 4 times sine square theta cos square theta. So this is equal to 2 minus sine square 2 theta divided by 2. What is the maximum value of this expression? This expression will be maximum when sine 2 theta is equal to 0 and the maximum value will be equal to 2. What is the minimum value of this expression? The minimum value will occur when sine 2 theta is equal to 1 and this will equal 2 minus 1 by 2, which is equal to 3 by 2. Therefore, the value of alpha plus 2 times beta is equal to 2 plus 3, which is equal to 5. So the answer for this particular question is option C, which is equal to 5. In this question, we are told that cos square 48 degrees minus sin square 12 degrees divided by sin square 24 degrees minus sin 6 degrees is equal to alpha plus beta into square root of 5 divided by 2. Alpha and beta are natural numbers. We are required to calculate the value of alpha plus beta. If you are looking at the numerator, cos square 48 degrees minus sin square 12 degrees. We would want both of them to be either cos or sin. So let us modify sin square 12 as cos square 78. This is of the form a square minus b square, which is equal to a minus b into a plus b. So this is cos 48 minus cos 78 into cos 48 plus cos 78. Now we know the formula for cos A plus cos B. What is the value of cos A plus cos B? Cos A plus cos B is equal to 2 times cos of A plus B by 2 into cos of A minus B by 2. Similarly, what is the value of cos of A minus B? Cos A minus cos B is equal to 2 times sine of A plus B by 2 into sine of B minus A by 2. So this particular equation, the numerator becomes equal to 2 times sine of, what is 48 plus 78? That is 126 divided by 2 is 63 into 78 minus 48 divided by 2 is equal to 15. Into, this is cos of A plus B. So this is 78 plus 48 divided by 2 is 63. So this is cos 2 times cos 63 into cos 15 degrees. This is the numerator. So the numerator, if you are simplifying, is 4 times sin 63 into cos 63 into sin 15 into cos 15. Now sin 15 into cos 15 into 2 is equal to sin 30. So this is equal to 2 times sin 63 into cos 63 into sin 30 degrees. 2 times sin 63 into cos 63 is sin 126. So this is sin 126 into sin 30 degrees. This is the numerator. Sin 126 is cos 36. So this is cos 30 degrees, 36 degrees into sin 30 degrees. This is the numerator. What is the denominator? The denominator is sin square 24 degrees minus sin square 6 degrees. So denominator will be sin 24 minus sin 6 into sin 24 plus sin 6. Similar to cos A plus cos B and cos A minus cos B, we also have two rules for sin A plus sin B. What is the formula for sin A plus sin B? Sin A plus sin B is 2 times sin of A plus B by 2 into cos of A minus B by 2. Similarly, what is the value of sin A minus sin B? This is 2 times sin of A minus B by 2 into cos of A plus B by 2. So now we have sin 24 minus sin 6, that will be equal to 2 times sin of 24 minus 6 by 2, which is 9, into cos of 24 plus 6 by 2, which is 15. into what is sine 24 plus sine 6, that is 2 times sine 24 plus 6 by 2, which is sine 15, into cos of 24 minus 6 by 2, which is 9. This is the denominator. Again, if you combine 2 cos 15 and sine 15, that is sine 30, because this is of the form sine 2a is equal to 2 times sine a into cos a. So this is sine 30 into, if you combine sine 9 cos 9 into 2, this is of the form sine 18. This is the denominator and we have, this is the numerator. So the given expression is simply equal to cos 36 divided by sine 18. Cos 36 is equal to square root of 5 plus 1 by 4 and sine 18 is square root of 5 minus 1 by 4. If you are simplifying it, this is of the form square root of 5 plus 1 divided by square root of 5 minus 1. We can multiply the numerator and denominator with square root of 5 plus 1 divided by square root of 5 plus 1. So this is equal to, the numerator is square root of 5 plus 1 whole square divided by square root of 5 whole square, that is 5 minus 1, which is equal to 4. This is equal to 5 plus 1 plus 2 times square root of 5 divided by 4. This is equal to 3 plus square root of 5 divided by 2. Now if you are looking at what is given over here, this is alpha plus beta square root of 5 by 2. So alpha is equal to 3, beta is equal to 1. The sum of alpha plus beta will be equal to 4. In this question, we are asked to calculate the number of natural numbers between 212 and 999 such that the sum of their digits is 15. So we have numbers between 212 and 999. Suppose the first digit is 2, that is, it is in the 200s. Then the sum of the remaining 2 digits has to be 13. So they can be either 4 and 9 or 5 and 8 or 6 and 7 or 7 and 6 or 8 and 5 or 9 and 4. So basically, if the first digit is 2, if it is in the 200s, there are 6 possibilities. Suppose the first digit is 3, that is, it is in the 300s. Then the sum of the remaining 2 has to be 12. So this 12 can be either 3 plus 9 or 4 plus 8 or dot 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 or 9 plus 3. Here we have 7 cases. So if the first digit is 3, 7 cases are possible. If the first digit is 4, the sum of the remaining 2 has to be equal to 11. So this has to be either 2 plus 9 or 3 plus 8 or dot 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 9 plus 2. Here there are 8 cases possible. Similarly, if the first digit is 5, the sum of the remaining 2 has to be 10. So it is either 1 plus 9 or 2 plus 8 or dot 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 9 plus 1. So there are 9 cases possible. Suppose the first digit is 6. The sum of the remaining 2 has to be equal to 9. So it is either 0 plus 9 or 1 plus 8 or 2 plus 7 or dot 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 9 plus 0. Here there are 10 cases which are possible. If the first digit is 7, the sum of the remaining 2 digits has to be 8. So it is either 0 plus 8 or 1 plus 7 or dot 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 8 plus 0. So there are 9 cases which are possible. Similarly, if the first digit is 8, we will have 8 cases possible, and if the first digit is 9, we will have 7 cases that are possible. So the total sum is equal to 6 plus 7 plus 8 plus 9 plus 10 plus 9 plus 8 plus 7. This is equal to 7 plus 8 plus 9 is 24 plus 6 is 30 plus 10 is 40 plus another 24 is equal to 64. So the total number of numbers is equal to 64 between 212 and 999 such that the sum of the digits is 15. In this question, we are given 428 to the power 2024. We are required to calculate the remainder when this is divided by 21. We know that 428 when divided by 21, the remainder is 8 because 420 is 21 into 20. So the remainder when 428 to the power 2024 is divided by 21, let us represent it as 428 to the power 2024 mod 21 is equal to 8 to the power 2024 mod 21. Now 8 square is equal to 64, which is 63 plus 1. Therefore, this is equal to 64 to the power 1012. I have just divided 2024 by 2 mod 21. Now 64 leaves a remainder of 1 when divided by 21 because 64 mod 21 is equal to 1 because 64 is 63 plus 1, 63 is 21 into 3. So this will leave a remainder of 1 to the power 1012 mod 21, which like we all know is equal to 1. So the answer for this particular question is that the remainder is equal to 1. In this question, we are required to calculate the remainder when 64 to the power 32 to the power 32 is divided by 9. One thing you will immediately notice is that 64 is equal to 63 plus 1. 63 is a multiple of 9. This is 9 into 7 plus 1. So 64 itself when divided by 9 leaves a remainder of 1. So any power of 64, whether it is 32 to the power 32 or just 32 or 100, any power of 64 will leave a remainder of 1 when divided by 9. Therefore, the answer for this question is 1. In this question, we are given two numbers. The first number is alpha, which is 4 factorial factorial divided by 4 factorial to the power 3 factorial, and the second one is beta, which is 5 factorial factorial divided by 5 factorial to the power 4 factorial. We are essentially asked to calculate which of these two is a natural number. Now, one thing that we would need to know is the highest power of a prime p in n factorial. The highest power of a prime p in n factorial will be n by p, take the integer part out, plus n by p square, take the integer part out, plus n by p cube, take the integer part out, and so on till the power of the prime is greater than n. The first one is alpha, which is equal to 4 factorial factorial, which is 24 factorial, divided by 4 factorial to the power 3 factorial. So this is 24 to the power 6. We are required to calculate if this is a natural number. What is the prime factorization of 24? The prime factorization of 24 is 2 cube into 3, because 24 is 8 into 3, which is 2 cube into 3. So 24 to the power 6, which is the denominator, is 2 to the power 18 into 3 to the power 6. What we have to calculate is what is the highest power of 2 in 24 factorial. Is it greater than 18? Similarly, we have to figure out what is the highest power of 3 in 24 factorial. Is that also greater than 6? The highest power of 2 in 24 factorial is 24 divided by 2, take the integer part out, plus 24 by 4, plus 24 by 8, plus 24 by 16. 24 by 2 is 12, plus 24 by 4 is 6, plus 24 by 8 is 3, plus 24 by 16, the integer part is 1. This is equal to 22. Similarly, the highest power of 3 in 24 factorial is 24 divided by 3, take the integer part out, plus 24 divided by 9, take the integer part out. This is 8 plus 2, which is equal to 10. So this is alpha is of the form 2 to the power 22 into 3 to the power 10 into some natural number n. This is the numerator. And the denominator is 2 to the power 18 into 3 to the power 6. You will notice that alpha therefore is equal to 2 to the power 4, which is 22 minus 18 into 3 to the power 4 into some natural number n. So alpha is definitely a natural number. Alpha belongs to n. We'll do the same thing for even beta. Beta is 120 factorial divided by 120 to the power 24. Let us first do the prime factorization of 120. 120 is 8 into 15, which is 8 into 3 into 5. This is equal to 2 cube into 3 into 5. So 120 to the power 24 is equal to 2 to the power 72 into 3 to the power 24 into 5 to the power 24. Now again let us find out the highest power of 2 in 120 factorial. We will find out the highest power of 3 in 120 factorial and highest power of 5 in 120 factorial, because this is the denominator. So highest power of 2 in 120 factorial is equal to 120 divided by 2 plus 120 divided by 4 plus 120 divided by 8 plus 120 divided by 16, take the integer part out, plus 120 divided by 32, take the integer part out, plus 120 divided by 64, take the integer part out. We have to take the integer parts for all of them, but I know that they are integers, so I didn't write it. This is equal to 60 plus 30 plus 15 plus 120 divided by 16 is 7 point something, so the integer part is 7, plus 120 divided by 32 is 3 point something, plus 120 divided by 64 is 1 point something. This, if you are adding, is 90 plus 10 is 100 plus 16 is 116. Similarly, what is the highest power of 3 in 120 factorial? This will be 120 divided by 3, take the integer part out, plus 120 divided by 9, take the integer part out, plus 120 divided by 27, take the integer part out, plus 120 divided by 81, take the integer part out. This is equal to 40 plus 13 plus 4 plus 1. This is equal to 58. So the highest power of 3 in 120 factorial is 58. Similarly, what is the highest power of 5 in 120 factorial? The highest power of 5 is 120 divided by 5, take the integer part out, plus 120 divided by 25, take the integer part out. This is 24 plus 4, which is equal to 28. So 120 factorial is of the form 2 to the power 116 into 3 to the power 58 into 5 to the power 28 into some natural number n. And the denominator, which is 120 to the power 24, is 2 to the power 72, 3 to the power 24, 5 to the power 24. So this given number beta is of the form 2 to the power 44 into 3 to the power 34 into 5 to the power 4 into n, some natural number n. So this also is a natural number. We have proved earlier that alpha is a natural number. Now we have proved that beta also is a natural number. Therefore, the correct answer is both of them belong to natural numbers, which is option C. In this question, we are told that there are two distinct numbers, A and B. They are selected at random from 1, 2, 3, dot, dot, dot till 50. The probability that the product A into B is divisible by 3 is supposed to be calculated. A into B is divisible by 3 if either A is a multiple of 3 or B is a multiple of 3. Now let us try to find out how many numbers are there from 1 to 50. Obviously, the total number of numbers is 50. In how many ways can A be selected? A can be selected in 50 ways. In how many ways can B be selected? B can be selected in 49 ways because A and B are distinct. Now, let us try to find out the number of ways in which A is not a multiple of 3 and B is not a multiple of 3. So, how many numbers are multiples of 3? From 1 to 50? The multiples of 3 is 16. It is either 3 or 6 or 9 or dot 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 till 48. So, the non-multiples of 3 is 34. So, if you are trying to select two non-multiples, the number of ways in which A can be selected is 34 ways. The number of ways in which B can be selected is 33 ways. So, the total is equal to 34 into 33. So, in 34 into 33 ways, we will get two numbers which are both not multiples of 3 and therefore the product AB is not a multiple of 3. In every other case, the product AB will be a multiple of 3. That is, the total ways is 49 into 50, which is equal to 2450. 34 into 33 can be calculated. What is 34 into 33? This is 102 and 1020. So this is 1122. Out of the 2450 ways, in 1122 ways, we are getting a product AB which is not a multiple of 3. In every other case, the product AB is a multiple of 3. So the number of favorable cases will be 2450 minus 1122. This is equal to 1328. And therefore, the required probability will be 1328 divided by 2450. We can divide the numerator and denominator with 2. So, this is 1225 and this will be 664. So, the required probability is 664 divided by 1225, which is option A. In this question, we are asked to calculate the sum of the squares of all the roots of the equation x square plus 2 times x square plus modulus of 2x minus 3 minus 4. There is one modulus in this and the inflection point for that modulus is x is equal to 3 by 2, which is equal to 1.5. This is where the modulus will change its sign. As there is one inflection point, there will be two cases that we have to consider. In the first case, x is less than or equal to 3 by 2. In the second case, x is greater than 3 by 2. If x is greater than 3 by 2, modulus of 2x minus 3 is equal to 2x minus 3. So this solution becomes equal to x square plus 2x minus 3 minus 4 is equal to 0. This is x square plus 2x minus 7 is equal to 0. So x is equal to minus 2 plus or minus square root of 2 square is 4 plus 28, which is 32 divided by 2. This is equal to minus 2 plus or minus 4 square root of 2 divided by 2. So it is either 2 square root of 2 minus 1 or minus 2 square root of 2 minus 1. These are the two cases that are possible. Here we are looking only for the values of x which is greater than 3 by 2. If square root of 2 is equal to 1.414, this will be approximately equal to 1.8, maybe 1.82. And this will be negative, this will be I think approximately minus 3.82. So this is not valid, only this is a solution in this particular interval. In the second case, where x is less than 3 by 2, modulus of 2x minus 3 becomes equal to 3 minus 2x. So the given equation becomes equal to x square plus 3 minus 2x minus 4 is equal to 0. This is x square minus 2x minus 1 is equal to 0. So x is equal to 2 plus or minus square root of 2 square plus 4. So this is square root of 8 divided by 2. This is 2 plus or minus square root of 2 root 2 by 2. So it is either root 2 plus 1 or 1 minus root 2. These are the two cases that are possible. Again, root 2 is approximately equal to 1.414, and so this will be approximately 2.414. This is root 2 plus 1 or minus 0.414. Here we are only looking for values of x which is less than 3 by 2. So it has to be 1 minus root 2. So this equation has two solutions. One is 1 minus root 2, other one is 2 root 2 minus 1. And we are asked to calculate the sum of the squares of both the roots. What is the square of this root? Square is 1 plus 2 minus 2 root 2. And the square of this one will be 8 plus 1 minus 4 root 2. The sum of the squares will be 3 plus 9, which is 12, minus 6 root 2, which is, if you are taking 6 common, 2 minus square root of 2. So the answer for this particular question is option A, 6 into 2 minus root 2. In this question, the number of distinct real solutions of the equation x into modulus of x plus 4 plus 3 times modulus of x plus 2 plus 10 is equal to 0 is given. There are two modulus in this, modulus of x plus 4 and modulus of x plus 2. So there will be two inflection points, which is minus 4 and minus 2. This is the points at which the modulus will become equal to 0. As there are two inflection points, there will be three cases. The first case is x is less than minus 4. The second case is minus 4 is less than or equal to x is less than or equal to minus 2. And the last case is x is greater than minus 2. If x is greater than minus 2, modulus of x plus 4 is equal to x plus 4 and modulus of x plus 2 is equal to x plus 2. Therefore, the given equation becomes equal to x into x plus 4 plus 3 times x plus 2 plus 10 is equal to 0. This is x square plus 7x plus 16 is equal to 0. This is a quadratic equation. What is the discriminant of this quadratic equation? The discriminant is square of the coefficient of x, which is 7 square, minus 4 times 16. This is equal to 49 minus 64. This is less than 0. So this will have no real solutions. If you are looking at the second case, where x lies between minus 4 and minus 2, modulus of x plus 4 will be equal to x plus 4 and modulus of x plus 2 will be equal to minus x minus 2. Therefore, the given quadratic equation becomes equal to x into x plus 4 minus 3 times x plus 2 plus 10 is equal to 0. This is x square plus 4x minus 3x minus 6 plus 10 is equal to 0. This is x square plus x plus 4 is equal to 0. This also is a quadratic equation. What is the discriminant of this quadratic equation? The discriminant is square of the coefficient of x, which is 1 square, minus 4 times the coefficient of x square into the constant term, which is 16. This is equal to minus 15, again less than 0. So this also will not have any real solutions. Let us look at the last case where x is less than minus 4. Here modulus of x plus 4 is equal to minus x minus 4 and modulus of x plus 2 is equal to minus x minus 2. So the given quadratic equation becomes equal to minus x into x plus 4 minus 3 times x plus 2 plus 10 is equal to 0. This is minus x square minus 4x minus 3x minus 6 plus 10 is equal to 0. This is x square plus 7x minus 4 is equal to 0. There will be two roots for this. X is equal to minus 7 plus or minus square root of 7 square, which is 49 plus 16 divided by 2. That is, one root is minus 7 plus square root of 65 by 2. Another one is minus 7 minus square root of 65 by 2. Square root of 65 can be approximated to equal 8 point something, 8.1 maybe, or 8. So this will be equal to approximately 0.55 if you are approximating square root of 65 to 8.1. In the second case, it will be, I think, approximately 7 and 8.1, 15.1, approximately minus 7.55. In this case, we are looking only for values of x which is less than minus 4. So it can't be 0.55, it has to be minus 7.55. So across all the three cases, there is only one solution for x. So the answer for this question is option A, which is equal to 1.